Smart meters. So this is to target the large meters. We can be used for all the meters, but first we start by optimizing the large consumers. So this will track the consumption of the customer. It will identify what's the profile of the customer, and every time that we see that maybe there is a deviation in their consumption, it will send an alert. It also adapts the best, it will identify the best solution for that customer, because we can, depending on the activity that we have downstream the meter, we need to adapt the technology. So one of the examples is that in one contract with 163 meters that represented less than 0.1% of the customers, and represent 15% of water utility revenues, we achieved 2 million benefit, so it was a return on the investment in 9 months for 1.4. Fraud detection. So when we have customers, the meters, they fail. There is a problem in the connection, there is a problem in the reading, there is a problem, we can have several problems. And this algorithm will allow us to check these deviations in the consumption. So what it works, usually we receive the result, the billing values. We check the anomalies, and we go to check on the field. When we have thousands of customers, the algorithm will allow to treat all this data daily, generate the on-site visits. Teams go to check if it's a fraud or not, and then they will upload information in the algorithm to make it, to enhance the algorithm. So in this, tested in 4 contracts, we had from all the on-site visits generated by the algorithm, we had 28% to 63% were real frauds. And in average, all the 4 contracts achieved a 400,000 euros recovery. So there are the tools to improve to reduce non-revenue water. We are using it mainly for plants management, for the water network performance, for demand forecasting. It will help predicting what we want to achieve is to get to the leak before it happens. We are already identifying some of these situations. So I would like to finish by saying that all this will be possible if we have a reliable information, a single source of truth for the data that we have, that we will upload in all these systems. And thankfully, today, we still need the people, we still need the expertise, because we need someone in front of these results to analyze and deploy the actions that will solve the problems. Because it will tell me where is the leak, but until now, it's not possible to be correctly automatically. So we still need someone to decide who is going and where is going to solve the leak. Okay, thank you. It's all.
Thanks, Nuno, for your presentation and information, which is correlating and taking us to the second presentation. The second presentation, again, will carry on NRW, which is the hottest topic in this session. The second one will be by Michael Bitven from Bitven Boss. Michael, he has more than 23 years of experience. He has a master's degree from Delft University in Netherlands. So he worked in several positions, including hydraulic modeling, NRW, and the most important for us in the Oman Water Services, he was the project manager for the contract frame between Oman Water Services and Whitveen Bos. Welcome, Michael, to your presentation.
So, thank you, everybody. Yes, it's working. Oh, this one is already done by you, so I can skip it. What I want to talk about today is the scope of the project that we did last year, which is to reduce the non-revenue water in the project area to an economic level. I don't know if the microphone works at this high level. And utilize various innovative techniques for leak detection and localization to determine which one was most effective. We did not do this alone. We had a combination of 3 companies. Whitveen Bos, of course, for the project management, data analysis and hydraulic modeling. Hulo for the leak detection and localization with AI and algorithms. And Blue Gold technology for all the field work, which was also quite extensive. Whitveen Bos is a consulting firm from the Netherlands, also based in Dubai and been active in the Gulf region for about 25 years now. We've been divided in 4 sectors. Today only the water and wastewater is relevant, of course, so we have about 200 specialists working in that field with all kinds of specializations. Then we have Hulo. Hulo develops software that helps water utilities achieve operational excellence with advanced network modeling software. So they use modular AI, physics-based technology, and their advanced machine learning predicts the sensor values and it detects anomalies, and it does all that within about 10 minutes after it detects something. So Blue Gold technology, also present here in the Oman Water Week. They're established in 2009 in the UAE and are specialized in pipeline monitoring and leak detection services, and they also represent several leading manufacturers of leak detection equipment. So now the project, as you can see, the project area is close to the convention center, which is located in the bottom left map, but it concerns Gala, airport region, and Bauscher. Okay, so this was the table given to us by the water company in the proposal stage, and as you can see, they're all areas with quite high non-revenue water figures, and an average cost price at the independent water producers of 27 cents. This already amounts to more than 2 million a year in non-revenue water just for these 3 areas. And that excludes the operational cost for Oman Water itself. So when you want to look for leaks, where do you start in this case? Well, in this case, we start in Gala, because that has the highest non-revenue water. And we also looked at the IWA water balance to see what components are contributing the most. Because, of course, yeah, you want to test all these techniques. They're all focused on reducing physical losses, but going in blindly, trying to survey the streets is not the most efficient. So you need data to guide your activities. So the importance of data, also mentioned by Nuna already, is of course to quantify the components in the water balance. To calculate the non-revenue water, quantify the water sold, but also to reduce physical losses. Because the data you need to create DMAs, you need to know where the pipes are, where your valves are that you need to close to create the DMAs. It's also used for your pressure and flow data. Right? You need that data in your AI algorithms. And you also need your data in your model that you need to locate leaks. So what activities did we do in the project? We start with the analysis of all this data in various sources. We did the boundary valve check, and we did the zero pressure test. So when we did that, we opened the box of Pandora. So we encountered numerous issues with the quality of the data. I think it was a secret goal of the project manager from Oman Water to let us uncover these and also point it out to the organization. So after that, of course, we did also the reservoir drop test, and we also tested all these technologies. But of course, first all these data issues. So what happened when you have these inconsistencies in data? Of course, it makes it difficult to understand your system, what happens exactly in the network. It's also difficult to notice mistakes, and because of that, it makes it easy to make new mistakes, which increases the issues. But more importantly, it also results in incorrect calculation of non-revenue water, and incorrect conclusions also where to focus your activities. So we actually shifted our focus to first identifying solving all these data issues, so we could understand what was going on and then take the appropriate actions. So after we resolved these issues, we updated the non-revenue water figures, and it had quite an impact. And then we created the conditions to be able to use the technologies that we wanted to test. So we also uncovered some important recommendations for Oman Water on how to approach the non-revenue water reduction. So first, starting with the customer database. Of course, it's used to determine the billed consumption, which is relevant. That's the revenues. But it also can be errors in the customer database can lead to commercial losses. So water is supplied but not paid for because of incorrect meter readings, for example, or the customer is not part of the DMA that you're trying to monitor. So some findings from the customer database were that many water meters were not existing or removed, but they were still in the database. There were meters with incorrect or duplicate coordinates. Meters were incorrectly linked to the DMA, and properties outside the DMA were linked to the DMA that were monitoring. Incorrect or inconsistent qualification of type of user or type of meter, not the worst issue for this particular work, but still annoying. And missing or incorrect meter readings. So this was just one example. We found 188 water meters had coordinates on this particular location, the entrance of a yard. Obviously, they were not there. So if you want to replace it or repair it, or even you're not even sure where it is, so maybe the meters are not even in this DMA. So it creates issues with your water balance. So the result of all these encountered issues was an incorrect determination of the amount of water which is billed, and also an ineffective management of the customer metering system. So that leads to incorrect conclusions for Oman Water. And in this case, we reduced the water demand in Gala's area, for example, with over 1,100 cubic meters per day, which actually increased the non-revenue water because compared to the inflow, now we have less demand. So let's continue with the rest. Sensor data, obviously mostly relevant for reducing physical losses and knowing what happens in your system. There are different sources of sensor data. So you have the SCADA, Lattice, the PI system, NetBase, and operations also made a list. So issues there were different tag codes used for the same sensor in different systems. The same sensor had different coordinates in different systems. No tag code of sensors in a NetBase map, so that made it difficult to identify which one it was. But in the Lattice system, there were tag codes, but no coordinates, so it was complicated to match them together. And a flow meter in the list from operations linked to FG1 did not actually feed FG1, so that all creates a massive confusion and complication to understand the system. And the fact that operations made their own list after having all these systems, yeah, just proves that they were also struggling getting an overview of what is actually happening and where the sensors are. This list. Also shows there's lots of sensors without data in the system. But for example, if you look at the top line, you can see several names for the same sensor, FG1, FM, GR1, GHRE, FIT005. It's all the same sensor. So one more example for the flows that we uncovered. We're actually testing the blue line, it's the main trunk line. And before that, we had to close a branch which was feeding the purple area, FG2 in this case. And that flow meter was giving 24 cubic meters an hour at that moment into the purple area. But when we closed the branch, the flow meter of the main trunk line increased with 80 cubic meters. So we uncovered it was actually a conversion error in the sensor from liters per second to cubic meters per hour. So that, of course, it creates a much bigger input into the purple area, and apparently not such a big issue in the area which was being fed by the main line. So, going on with the GIS database, of course it's used for the hydraulic model as an input. Where are your pipes and valves? And it's important to create DMAs. Well, some findings there. There were missing pipes in the system, but also pipes in the system that did not exist actually. Incorrect valve positions, incorrect sensor locations, PRV was not included, and incorrect reservoir size data. And this is one example where you see that the network is connected, but in reality it was not connected. So of course that makes a big difference in where the water goes to. Also this PRV, quite big one. Obviously some departments in Oman Water know very well that it exists, but not the GIS department and not the hydraulic modeling department apparently, because it was not in their systems. So some conclusions from the GIS database is that because of all these issues that we uncovered, it was not possible to separate some DMAs because nobody knew where the valve was to close the pipe, or there was a secret pipe still feeding the area that nobody knew about. Yeah, because of the mismatch with the reality, of course, the hydraulic model is also not giving accurate results, which also impacts the leakage localization algorithms that we try to use. And obviously, it also impacts the non-revenue water calculations with open DMA borders. So we implemented all the changes and improvements from the databases into the hydraulic model, which is mentioned here, and then we were ready to test the innovative techniques that we were trying to do from the start. So we did all that, and that is, unfortunately, I'll limit it to this summarizing sheet, because in this case, the zone scan was found to be very effective for distribution networks, especially when used in combination with AI. For main trunk lines, it was a trunk main correlator was most efficient, and no-dig was very successful in repairing leaks without the need for excavation, which is of course a very big benefit. And using innovative techniques in combination with conventional techniques such as the noise loggers was extra beneficial, because you can send the teams right in the right direction before, and they don't have to survey the whole area. So, looking at the leaks that we found, is this list. Gala has the most because we focus the most on Gala. And still, if you put that in perspective, it's not that much. Because if you look at the leak that we found, most of them were service connections, also some larger ones, but yeah, then it amounts to like 30 to 60 cubic meters per hour. But if you look at the total non-revenue water given, 340 cubic meters per hour, then it cannot all be, apparently it's not all caused by leaks, it's caused by other things as well. And we searched intensively with all these techniques mentioned before. I'm sure we did not miss much. So if we update the non-revenue water calculation, you can see the result from the data cleanup is considerable. And after leak repair, which is, of course, maybe new leaks occurred in the project also. We did not take that into account. But then we end up with a great result. And I think if Oman Water would have known before the project that they only had 20% of non-revenue water, they would have sent us to another area. So I think the main conclusion here is that in this case, it was the non-revenue water was caused by commercial losses and not by real losses, but also that incorrect data leads to incorrect knowledge on which the strategy to reduce non-revenue water is based. So then you go to the wrong area to put your money in. So my main recommendation is to develop a plan within Oman Water to tackle the many issues with the poor data quality, and that will really help you to reduce the non-revenue water. And clearly there's a multi-headed problem that you need to tackle with all different departments together. But yeah, if successful, the treasure will also be quite as big. So thank you.
Thanks, Michael, for this fruitful presentation. You were lucky to get this project. Otherwise, as you said, less than 20%, no need to do it. However, just to highlight one more thing, I think Nihachi is here. You touched one of the most strategic project in Oman Water Services for this year, which is the asset register and the update of the GIS database. There are now currently several projects on this field. Hopefully you can meet, yes, Nihachi is here, so hopefully you met Nihad and she will update you more on this topic. Right, so this presentation takes us to the next presentation, which will be more strategic. The one will be delivered by Simon. Simon, he's from WRC, and he's the project director here for the sector. Simon, he has more than 27 years of experience. So Simon, yeah, welcome to the stage, and let us see the strategies that you have. Thank you.
Good morning, everyone. Welcome to Wednesday. And I think, let me start by just recapping the previous presentations. Nuno linked us into the art of the possible with some of the AI solutions out there, and also quite a nice introduction for the day around the basics of non-revenue water, which I think is good just to set the scene. And you ended with bringing up the human expertise, the human in the loop, the human delivery aspect. I'll pick up on that a little bit as well. Michael, you also picked up on data, and Nuno, you mentioned it as well, one source of the truth, and that underpins a lot of what I'm going to talk about as well. But I am going to link it into a bit of strategy, and hopefully just leave you with some questions and some thoughts. So about me, it's not really all about me, is it? It's about you in the room. But I'm a chemical engineer, 28 years experience now. I've worked in food and drink, oil, gas, petrochem, in the last 8 years in the water sector. So I've not got the non-revenue water expertise that my colleagues have, but what I have got is a lot of experience about solving problems, both in the UK and internationally. WRC, if you don't know us, we were the former Water and Wastewater Research Centre for the UK government. So we were all civil servants, founded in 1927. Just to be clear, I wasn't founded in 1927. But the business was, and we were privatised in the 80s, and we're an independent consultancy that tries to solve really difficult problems. That's why we exist. We're about 230 people. And last year, I'm proud to say that we opened our first international business right here in Oman. So we're investing in Oman. We employ both UK nationals here in Oman, but also Omanis, which we're really proud about. And we have a career development program in place for those individuals as well. So we're really, really pleased to be here. So I want to start off with something around big pipes. And Michael, you mentioned it as well, looking at some of these larger diameter assets, transmission mains, sometimes working at higher pressure, particularly in some parts of Oman where you do have really mountainous regions and you're having to lift water up to great heights. Certainly from a UK perspective, these assets are really only just starting to be looked at, and there is this perception around large diameter mains that they don't leak. I've heard it from utility companies all around the world. And you'll talk to them and I'll say, what about your transmission losses? And they'll say, oh, it's nothing, it's 1%, 2%. We're not focused on that. We're focused on the distribution assets in the towns and the cities. But of course, and I think you'll understand this, roughly speaking, 2% on a very big pipe is a lot of volume. And it shouldn't be ignored. Now, the reason why it is ignored or pushed to one side is the cost of investigating where those leaks might be, assessing the condition of those assets. But also, once you've found the leak, what on earth do you do with it? It's expensive. These are big, deep excavations, and the repairs are expensive to achieve as well. So let's make sure that we don't forget those, but also prioritize those against and balance them off against the necessary investment as well. So on the image on the screen, just over on your right-hand side, we're actually inspecting pipes in the UK at the moment. These are large diameter pipes that are heading towards 75, 80 years old. And we're doing dead inspections on those at the moment. Those pipes, there's probably about 100 kilometers to inspect. They are actually in not bad condition, but they have water quality issues with them, as you can probably see by the image. So the contractor there is lining those pipes. So we're employed to go in and assess the condition before the lining works, and then we come and assess it afterwards just to make sure the lining's been successful. So sticking on the theme of big pipes, you know, we talk about water balances and we tend to think of that in the regions around the towns and the cities and the places where people live as well. These big transmission pipes, you can also balance those off. Okay, it's perfectly possible to do that. We've done that not so long ago for a client in the UK where we created over 600 individual balances across the transmission pipe network. Why did we do that? Well, we wanted to try and find out, or the client wanted to try and find out, where the water was going. They had some readings that didn't make sense. They didn't know whether it's real losses or apparent losses, and they wanted to find out. So we went about producing these trunk main balances, and from each of those 600, we produced a proper intervention strategy with recommendations for what to do, along with the necessary investment to do it. So again, this comes back to this balance of we have a technical need, but what is that commercial investment needed, and what's the reward going to be? And that led us to one particular asset in particular, and we also have teams of people that inspect pipes in live conditions. So once we had the theoretical approach defined, we were able to go into the field and actually deliver that inspection, and on day one we found a 2 MLD leak. So it started to validate that that approach works. So there are techniques out there for looking at these big assets in a theoretical way before you spend any money, and then you can validate it. The challenge as well with those large assets is bulk meters, and again that came up in the previous presentations as well, that meter accuracy piece. And this is just to reiterate that if you didn't know it already, you can check those meters relatively easily and relatively cost effectively with clamp-on ultrasonics. There's plenty of suppliers out there that do it. We offer services that do that as well. So again, you've done the theory, you can check that data, and it comes back to data and one source of the truth. You can check that data before you go any further. So a wise and easy investment. And you might, of course, want to look inside the pipe. Why would you want to do that? Well, these days you can look inside a pipe visually, and you can use acoustic leak detection covering many, many kilometers of pipeline asset. The technology's there, it exists. But what you've got to do is use that theoretical approach to put your strategy in place to work out which technology to use and where. Because not one technology is going to deliver the results you need in every location. So in some locations you might want some push rod technology. It goes a very short distance, but it's quick and easy to deploy. Deploy it via an air valve, deploy it via certain types of hydrant. Quick and easy, you can buy it, you can be trained to do it yourselves. Right the way through to robotic inspection devices. The one in the center of the image there, that's the one that we use. Actually, we've used it here in the Kingdom of Saudi, sorry, not used it here, we've used it in Saudi Arabia, working on the NEON project a couple of years ago. Ball type technologies we've mentioned as well. Again, these are great technologies, but you've got to know where to deploy them and for what benefit. If you do that, that ultimately reduces your investment, and your operational risk. So moving from some of those bigger pipes into some of the smaller ones, and really that's the focus of a lot of NRW work here in Oman. And first point is, and I'm guilty of this, I use percentage terms. We've used them this morning as well. The percentage of leakage, percentage of non-revenue water. Michael, you picked up on some actual volumes as well, which is what we need to do. We need to change the language to talk about actual volumes. But percentage is just the way the world talks about it, unfortunately. And there are some brilliant examples of low NRW networks, places like Tokyo, Dubai, etc. And then there's the UK, sort of mediocre really, somewhere around about 20%, depending on where you look. So that's why I'm here, because I think we've got plenty of lessons to learn from the UK. That's why we built our business here, because we want to share that knowledge with the country of Oman. So for those countries that are in really high non-revenue water situations, sort of 40% plus, there's a real benefit, a real opportunity to make step changes, because at high non-revenue water, actually the changes you need to make are relatively straightforward to get you down to these lower levels. When you get lower and lower, it becomes a harder and harder journey, both technically and from an investment perspective as well. So high NRW is investable. And why do we need to bother? The points are on the screen there. You know, we need to decarbonize, we need to become more sustainable, we know that. There is finance available. Internationally, the big lenders like funding water. It's considered sustainable, it's considered essential, and it's bankable. So those big NRW projects are fundable. That's something not to forget. It creates jobs. We can upskill, we can build capacity. GDP growth, there's some good reports coming out now around big NRW programs generate GDP, and it is actually measurable. So I think that's something to think about as well. And of course, R&D and technology. There's plenty of technology here at the event that you can go and see, and we need to see that continued investment coming through, and the way to do that is by delivering these programs. So let's say we start off with a well-considered plan, a strategy. And if you look at the graph on the screen there, I think you'll see that after some time, you get some improvement. Non-revenue water starts to fall. So you get a benefit, and everyone starts patting themselves on the back, going, we're doing okay. And then it starts to flatten off at some point, And the question is, why? And this is happening in the UK. And the reason, to me, as an engineer, seems quite obvious, actually, is actually we're using the same people, processes and procedures that we've always used, the same materials, the same contractors. So are we going to realistically expect change that sticks? And the answer is no. I think it's quite logical. No, if you're doing the same things, you're probably going to get the same result. So at some point, you flatten off on the benefits curve. And this is what's happening in the UK. You know, we're still using HDPE, PE100, PE80 networks, and we're building them in the same ways that we were doing 30, 40 years ago, sometimes with the same people and often to the same procedures. And even on new networks, we see inbuilt non-revenue water, inbuilt leakage of about 10% on new networks. Those networks will pass a pressure test, give it a couple of years, they'll start to leak again. So we really need to remember that there's going to need to be some element of people and procedural change to deliver non-revenue water strategies. So it is about business transformation. It is about people. The roadmap, and again, this came up this morning as well, that strategy, that roadmap, based on validated data, one source of the truth, not in different silos, not in different departments, one source of the truth that's validated to drive everything else that we need to do. Every intervention that's made needs to be really carefully considered, not just in terms of that MLD reduction, but also in terms of capacity and capability to deliver that and make it stick for the long term. In those interventions, ALC, pressure management, service pipe replacement, meter installation, they've all got different skills, and you have to get them right. I was talking to someone yesterday about ultrasonic meters, and the need to get those installations absolutely correct. If anyone's ever installed any plumbing at home or even an ultrasonic meter, if you use some PTFE tape on those meters, just maybe to nip it up and make sure it doesn't leak or drip at all, if any part of that tape is in the flow path of the meter, with certain meters, you will get inaccuracy. So it's really important that you get right down to the detail of who's installing them and how are they doing it and to what procedures, and to monitor that quality. So we see a variety of different pipe installations around the world. And I have to say that this is not intended to be critical of the people that install mains and service pipes. It's a really tough job. I've worked out on site many, many years ago. As you can tell from my hands, I've not done it for a long time. But I've been there. I've been on site in the wind and the rain and the mud in the UK. And over here, yes, it's warmer, but you're going to get sand material. You're going to get fine dust and stuff in the air. Those are not great conditions for installing anything. And you can look at it online. You can look at how electrofusion fittings fail when you have a tiny bit of dust in the air. They'll pass a pressure test for sure, but you can pull those fittings apart in a vise on a bench. So we really need to focus on those installation techniques, that control of quality, that's absolutely key, and helping our teams on site have a very clean, quality-controlled environment. And that's not easy, but it is achievable. And when you do that, you go from asset lives of a few years into your 75 and your 100-year asset lives. We've not solved this in the UK, by the way. This still isn't solved. This is a problem across the world. So, what am I talking about when it comes to people? I think everyone is used to working to standards and procedures. So when you embark on these campaigns, check that you have them in place. Check that they're current and they're valid. Change materials if you need to. Just do it. Change contractors, retrain contractors. Work on those installation techniques to give that cleanliness of environment. Make sure quality control is always carried out. And all of that can be done now and is being done right here in Oman with relatively quick results. It's not easy. Changing people is the hardest bit of all of these programs because the technology's there, the theory's there, the AI's there, the data needs cleansing and sorting out. That can all be done. It's the people aspect that's the tricky bit. So last sort of technical slide before I wrap up. I touched on meters earlier, and there's a question on the board there. I'm not going to ask anyone to answer the question. But just imagine this. So if you're selling meters or manufacturing meters from a reputable manufacturer, pretty much anywhere in the world, there's a lot of Europeans do it, those meters are incredibly well made. No criticism there at all. And they're well tested. They've been developed for years to be excellent meters, and they are used widely around the world. But if I have one of those meters on my house, would I realistically expect it to be performing the same as perhaps one of your homes here in Muscat? I would argue no. And the variable, I think, several variables, but there's a water quality variable, there's a water temperature variable, there's a source water variable, there's an ambient temperature variable. And we do a lot of work on meter testing, and we are seeing increased levels of critical meter failures in the Middle East. We're investigating that at the moment. If anyone's interested, come and talk to me afterwards. But that's a concern, and it's a concern that a meter that's made perhaps in Europe might well be tested at 55 degrees C ambient, 60 degrees C ambient. With climate change, the temperature in this region is going up and up and up. And if you put a meter in an enclosed chamber, you've created an oven. And depending on where you are, coastal or inland, you might be creating a humid, hot and saline environment that perhaps those meters weren't tested for. So just a word of future thinking. Is it a critical problem today? No. With climate change, could it be in 5 or 10 years? Maybe. And of course, meter battery life, we might be looking at 5 or 10 years. So now is the time to start thinking about what's coming up, what's coming over the horizon that could impact us, that could impact the one source of the truth, that reliable data that we need. So, Wrap-up time. Technology, definitely part of the solution. I love tech. It's great. Most of it that we need right now is available here, so use it, engage with it as part of a plan. It'll only have short-term impact if it's hastily procured and not linked back to that overarching plan, that strategy with clear benefits articulated. And for me, it's people, processes and procedures that are right at the forefront of our net zero ambitions. There are a couple of QR codes on the screen. If you would like to scan them, please do. The first is my LinkedIn profile. I'm really happy to connect and continue the conversation. We're also based over in the innovation area as well that we're sponsoring as part of this conference. Finally, the Global Leakage Summit is happening. We are sponsoring that. Headline sponsors are Saudi Water Authority. We've got people from NAMA attending as well. So that's coming up in May. Again, register now. Any questions, please come and see me. It's a truly international conference, and it's shaping up to be a good one. Thank you for the invite to speak, and I'm here for the rest of the day. Thank you.
Thanks, Simon, for your presentation and this insight with open-ended questions. Let us ask a question given the flow meters. Right, we had 3 presentations from consultancy services. Let us now hear for a 4th presentation from Khalil Al-Adawi. Khalil Al-Adawi, he is the water losses section head in Nama Water Services. Khalil will talk again about an RW from client perspective. Welcome, Khalil.
Assalamu alaikum. Good morning, all. Let me to take you a short journey to show you our journey in NRW. I will start to give you a brief about Nama Water. In Oman, the water management started since more than 50 years. I'm going to focus just only in last 3 years after we starting Oman Water and Wastewater Company and Nama Water. I will give you a brief about Nama Water service. We are having more than 2,400 operational assets in water sector, and we have more than 25,000 kilometers of networks, including transmission, distribution lines, and surface connection. We have more than 500 DMAs. Also, we have more than 730,000 customers for all the governorates in 10 governorates, as we know that Nama is operating in 10 governorates in Sultanate of Oman. This is something interesting here to show you, that our production starting 2009 up to 2024. We can see it in 2009, we're producing just only 150 million cubic of water. By end of 2024, we're producing 3 times more. It is 450 million meter cubic. This because of the growth in the network, growth in the number of customers, and everything. Something interesting, if you can see it in last 3 years, starting from 22 till 2024, we can see that the growth it is coming down. Behind that, there is a lot of efforts done in Nama, and we can go through it. Here, it is showing that our journey from UFW, we started in 2021 with almost 42%. We ended last year with 37%. We reduced it around 5%. Guess I'm going to focus in the technical side. I'm not going in details about the commercial side. As Nama, we are focusing in gas in 4 areas that we believe this area, it will help us in reducing the technical losses. One of them, the most important about the data management or data analysis. Also, we focus in active leak detection also pressure management, and finally, we are going to talk about water network developments. So we are trying to bring ourselves from the big box, which we have it now around 37%, to the economic level of leakage. I will start with the data management. From the chart, you can see it. Since 2019 up to 2024, we started with 20% of the data. By end of 2024, we did a lot of efforts to improve our data. So now we are exceeding 85%. Not just only the available of data, we are taking care about the quality of the data. The red line, you can show it. It was in 2019, we are below 20% of the data which we can use it. But by end of 2024, we are exceeding 80% in that data which we have it and trust it. So we have the data and everything. So we need a system to monitor all this data. So we have leakage system. We have input 3 sources from the CCB, the billing readings, GIS data, and we have also the SCADA data, which are taking the flow and pressure. The net base is doing the calculation and everything. We did analyze, we calculate the losses, and based on that, we take the actions. Here, to give you a summarize about our SCADA, net base dashboard, we have the customer data, we have flow data, we have GIS data, everything that is available now with us. So this is push us to understand what's going on in each DMA, in each area. So now we have the losses per DMA, we have the losses per governance. For that reason, we start now creating the actions by getting this information, all of them. So I will start with the pressure management, which is the most critical things that and give you fast run safe. So NEMA have approved the strategy for pressure management, and we have installed more than 600 PRV in all distribution networks. This strategy based on what? We try it, if you can see this chart, most of our DMAs, it was having high pressure and also high leakage. We tried to build our strategy to bring all the DMAs to this box, which is showing in the left side, that we are trying to manage the pressure between 15 meters till customer meter. After starting implementation, the pressure management, we start seeing the results, and we can see it. We started by installing BRV, then we move in advance by installing E-timers in some BRVs that to reduce the pressure at nighttime, because we don't want to keep all the lines or distribution networks in stress all the times. And we're starting getting the good results from this pressure management. Second things, active leak control. As you know that we started with 13 leak detection teams in NEMA as a local teams, but we have more than 500 DMAs, and it is very hard to cover all these DMAs with the 13 teams. We go to other side by adding more teams. We did frame contractors with 3 companies experience. We increased the number of teams to 28 teams, and these teams are distributed in most of the regions, or we are focusing currently in the highest area. So we can see it after starting active leak detection. This is one example. We can see the drops in the losses in these DMAs. In other side, not just only we have a teams, also we work to bring the newest technology. We are trying to bring the newest equipment to the leak detection teams. So we supply it listening stick, drum microphone. We are using hydrophones, noise logger. We are using gas leak detection, and also colorimeter and pressure loggers and pipe mic And also, we use one technology here, which is started with NAMA. It is drone leak detection. As you know, that the transmission line surveying is taking time, but we bring it by drone. We use a thermal camera, and this give us a good, quick survey for the transmission line. Also, one of the main projects which we have it, satellite leak detection. We are starting since 2018, and this technology is help us to find more than 30,000 leaks from 2018 till today. This technology help us to speed up survey in all the DMAs. The last section, it is water network developments. NAMA, maybe let's say before 2021, our reputation, our pipe replacement, it was below 0.3%. In last year, NAMA has been approved a new strategy that we are targeting ourselves to replace minimum 2% from the network. To speed up the work, we allocate the budget 13 million Omani Riyal for 12 areas in Oman. And also to speed the work, we awarded to 60 contractors. Each region, we have 5 contractors. These things, to push ourselves, to target ourselves, to complete at least minimum 2% from pipe replacement. We start getting the results from last year that we can see it. There is a big improvement in some areas by replacing the old pipes. We can see, for example, this DMA, it is Qurayat DMA. It was almost 250 cubic per hour in the flow, and it was most of that water, it's leakage. We bring it down almost now, it is close to 50 cubic per hour. So we wish all our DMAs, after completing all the rehabilitation, will see the same results here. Also, on the other side, we are focusing in reservoir repairs. We did also allocate a budget for reservoir repairs. In 2024, we started, and we are completing in this one, and already some reservoirs completed, and we are accepting to get saving around 2 million cubic per hour, 2 million cubic per year. So with all that efforts, we can see it, our journey started from 2021, and the production, it was increasing about 3 to 5% yearly. No, now we stop it. Even in 2024, we reduce it. We produce around 450 million cubic, which is less than which we produce it in 2023. And also we can see it, the technical losses. It is coming down from 420,000 cubic per day. Now we are below 250,000 cubic per day. Our journey, it will not stop here. Still, we are continue our efforts and our strategic plans in next 5 years to reach to 24%. Thank you so much.
Thanks, Khalil, for this fruitful presentation. Really, you show us the great efforts that even us, we are working with you, but we don't know all of this information. And you are linking again with the previous presenters that you still need a human being in order to do all of these efforts with more than 18 teams. I think the next presentation will be with AI, and he may help you. So the next presentation will be with Mr. Lloyds. He will talk about the AI efforts that will be done in the NRW. So welcome, Lloyds, to the board. Thank you.
So let's check if you're still awake. Stretch, stand, move a little bit. Excellent. You know, we're not going to talk about AI because AI is sitting here in the auditorium. I'm going to be talking quite a lot about people, and there's going to be interesting reasons why I talk about people. One of the topic areas I cover in Gartner is around sustainability, and in sustainability we talk about water, we talk about electricity, and we talk about climate change. So I come from a little country right down there at the bottom of the map. Sorry, get the right button. And I don't think it's going to show. No, we can't. But let me walk. Right over there. So South Africa is a very water-stressed country. And if you look at that map, you're going to see that by 2050, 2.4 billion people are going to live in water-stressed areas. So what you saw from the previous presentation is paying attention to leakage, reducing leakage improves your sustainability, is going to reduce your future water stress. And when we don't pay attention to leakage rates and we don't pay attention to non-revenue water, we raise the stress in the environment. And what we know in the next couple of years is that we have got climate change. Climate change waits for no man, no tariff, and the climate is warming. As we watch this process unfold, we've got to ask the question, what lessons can we learn from around the world? So I'm going to play the role of Chief Reminding Officer, and I'm going to tell you about the story of the city of Cape Town, one of the first cities in the world to hit day zero and just about fail. So if you've not been to Cape Town, put up your hand. Okay. Go to Cape Town, ride the cableway. Amazing city. You can get to the top of the mountain. The city is built all around the mountain. Amazing food as well. Amazing people as well. We'll talk about crime a separate time. But what we want to tell you about is the drought that hit the city of Cape Town, and this is in 2019. And the problem was that the El Nino caused a shift in the rainfall pattern, and the city found that they were going to hit day zero. Because the water levels in the reservoirs were dropping to below 10%, you could not abstract the water. So now the city had a crisis. How are they going to get this behavioral change? Because we also need to pay attention to consumption. And the city found that they had a very interesting data quality problem because they wanted to name and shame high users. And they produced a very, very interesting map. They charted every single meter, put it on a map, and then they color-coded the dots. And then they started to tell neighbors about who was consuming more water than their fair share as a way to create pressure, to create social dynamics and social incentives to reduce consumption. Now, you might say, well, what does this mean? The drive was to reduce consumption by about 40% in the city, and the water restriction said you're allowed 50 liters per person per day. 50 liters. Okay, what does that look like? Well, think of an average toilet flush. That's about 11, 12 liters, depending on design. So that is how desperate they were. And of course, they had a very, very strong campaign driving this message of we all need to use just 50 liters for 150 days, and then we're going to be able to rely on the rains and to fill those dams. So what was at work here? Great data quality, good network modeling, amazing communications. What did they get? Social buy-in, adoption, and follow-through. So what we've seen this morning is all about technology. But at the end of the day, technology doesn't help because it's about people. And I want to talk a little bit about people, and I want to talk about our attitude to digital, because our attitude to digital determines whether we're going to succeed or fail with AI. So when we think about digital water, it's a very exciting topic because, we're going to be able to do all these amazing things with digital water, particularly because we've got great data. But when we survey CEOs of water companies, of utility companies, do you know what they say? I am really disappointed with all these investments I'm making in digital. In fact, the data says 57% of the CEOs are very disappointed in the investments that they've made to improve asset utilization to reduce those water leaks, and they're disappointed. It's really important that we understand why they're disappointed. And we think that inappropriate digital transformation is leaking a lot of value in our organizations. So what does inappropriate digital transformation look like? It's when our ambition that you see out there on the left, sorry, you're right, exceeds the reality on the ground. We all know people that you put out into the field and they will walk past a pump and they will say, "Can't you hear the bearing is failing?" That old guy has amazing experience, amazing knowledge, and great intuition. But we haven't captured his knowledge and we haven't captured his insight, and he's about to retire. And that is our problem. We've got a digital attitude, a cultural value in our organizations that hinders our digital ambitions. And that's going to be a big barrier. So what does it look like? Well, a digital attitude that says, you know what, I don't do that stuff here. How do I know? Well, I've got a bit of digital apathy. I've got digital silos, different departments who don't talk to each other. We don't share the data. We don't collect the data. We don't fix the data. We've got a data quality problem. So I want you to come away from this session, and I want you to remember just this one thing. Stop talking about data quality. I want you to talk about data risk. Because if you've got bad data quality, you have got operational risk. It means you just don't know. So when you say data quality, it becomes someone in the back room's problem. When you say data risk, it's an operational problem and it is owned by us collectively. Very, very important to make that shift. Then we find a lot of organizations starting to break those digital silos, and they're saying, we want to move to awareness. We want to measure what is happening on the system. We want to understand where those leakage rates are occurring. And so we're going to install smart meters. We're going to deploy lots of sensors across the system. And we've got lots of data. Lots of time series data is actually worthless. Because if I don't take that time series data and ingest it and use it to make adaptive operational decisions, it's wasted investment. So what are we going to do when we adapt? We're going to look at that data, we're going to interpret that data, and we're going to make decisions and take action. A lot of times we get people admiring the problem, seeing the data, doing great work in analyzing the data, but not following through and executing to the point of completion. And then we're going to talk about how do we find advantage from that operational adaptive response. So how can I find advantage? Well, advantage could be new levels of optimization. How do I optimize my pressure management? How do I optimize the hydrology across the system? And one day, we're going to talk about fully autonomous systems. Now, you're going to look at this chart and you're going to go, wow, that's a big change in attitude. I'm going from I don't care to a world where maybe machines will do a better job than people. Now, how long is it going to take to go from this left all the way to the right? Some of the oil companies are doing this amazingly well. They've taken about 10, 12 years and they've traveled from the left-hand side of this picture all the way to the right. And I will never forget this experience with one of my oil colleagues. We were talking about leakage rates, and I was saying, yeah, the problem with the water industry, we're about 40% in some sectors. Some countries we're down to 20%. One or two countries we're down to about 3-4%. And he looked at me and said, that is shocking. If we have one leak, it's a catastrophe. So this problem can be solved. We've got a problem with our attitude. And so what I want to take away from today is, how do we shift your attitude? How do you change your attitude, and how do we change our response? Because we have an imperative we must solve. So let's show you some technologies that we see our clients typically deploying. So when we think about digital apathy, we're going to say we've got a SCADA system, we've got a billing system. They're all there standing in silos, not appropriately connected. And we focus on asset performance. When we want to lift the conversation to understand how is the system performing, then I deploy sensors like smart meters, like IoT, and I measure what is happening. I'm measuring the context. So I'm extending the reach of my SCADA, not only to do sensors and actuators, but to get hold of context. And all of that time series data is very useful when I plug it into a digital twin. So that's one technology set that we've seen demonstrated this morning when we were talking about NetBase. It's a great example of a digital twin. Because what are we doing? We are consuming all of that time series data, and in consuming that time series data, we're analyzing it, we're finding those trends, we're finding those events, and then we're triggering action. So we're generating the insight to take the action. But then we can see the emergence of software-defined assets. So think of all those pressure reduction valves we're deploying all over the network. I can talk to that valve over the air, and I can reconfigure that valve every day. So this idea that I apply one configuration file and leave it forever and never change it is false. So I can actively manage the system. I'm no longer just deploying a passive system. That means that I don't have to invest for the peak. I can actually reduce the peak because I am actively managing the system. And then in some sectors, we're going to talk about autonomous energy, autonomous water. Maybe it's a little bit far. But I want you to think about the energy-water nexus, because we need energy to desalinate water, but actually we also need water to be able to manufacture energy. So it's a very interesting circular system. And in the electric utility world, we talk about a future where the electric world is going to be a grid of microgrids, completely autonomous, running independently of humans. That's a little bit scary. Now, we did have a promise of AI, and I would be doing you a lot of harm not to talk about AI. And the one use case that I think is really, really important for AI is to use AI to pay attention to your data risk. Please make sure that you are using AI to reduce those gaps in your data. So we can do that with synthetic data. We can use AI to generate that synthetic data. But what is more interesting is I can use AI to fill in all those missing bits of data, because I can learn from the context. And that is a really important step. That's going to help break that apathy stage. When I'm in awareness, where do I want to use AI? I need to use the machine learning to do that trend analysis. You know, as a person, I lose attention after about 4 minutes. So I want a machine to find those trends for me. When I'm looking for adaptive models, I'm looking for a grid twin to be able to understand what does the water grid look like, how does it behave. Can I actually run simulations using AI and solve in near time? And the answer is going to be yes. We can do that with a high degree of confidence and with actually quite low error rates, if we've paid attention to data. Yeah. So with that, I want to show you one slide and talk a little bit about what we need to do. So when you think about your asset practices, how do I know that you're struggling with digital apathy? It's because we still talk about time-based maintenance. How do I know that you've moved beyond apathy into awareness? I look at your maintenance regimes, and I go into your enterprise asset management system, and I see that you are adopting and implementing usage-based PMs. That means you're measuring. You understand how often the asset is used, and because you understand how the asset is being used, you are shifting your maintenance regime. And then we're going to talk about condition-based maintenance, where I'm measuring the health and quality of the condition of the asset. Maybe one day we're going to talk about RCM. There are many utilities who pay lip service in this space, but when we have a look and we ask, how do you manage all your individual assets in the system, the center of gravity comes back down towards the left-hand side of this chart, and we find people stuck at level 2. So what do you need to do to change this? I want you to think about how, as a business, we create value. It's about how we maintain and operate. But I can't maintain and operate if my asset is not in the asset register. We heard that quite a lot this morning. If the asset is in the asset register and I don't understand the asset's condition, well, what a waste of time. Because I would like to understand the asset's condition so I can compute the asset health. And the way this business rule works on this little chart is an asset is at condition 5, I expect it to fail before the next piece of planned work if I don't know about its data. So don't allow people to pull the wool over your eyes and say, we've got great asset data. If I don't know the condition of the asset, well then I can't compute the asset health. And that means the asset health is at risk because it's 5 because we just don't know. When we get on top of the asset health, then we can talk about working out that asset risk. How do I know this? Because the asset risk is a function of the asset and the number of customers connected to the asset. That gives me a good view of the criticality. So when I come to utilities and we want to talk to you about your asset management strategy, I don't want to hear about ISO 55000 or all those other great and important standards. I want to understand how many assets are sitting in the top right quadrant of that matrix. And remember the business rule. If I don't know, it scores a 5. So there is your asset management strategy, your data de-risk strategy on a single page. What do we all depend on? We depend on a great asset model, and with that, I'm going to hand back to our chair because standards count. Thank you so much.
Thanks, Lloyds. That's really bring us to very, human being dependency again, which is very great for all of us. And as you said, that relying on computers may not always the only solution. Of course, a lot of people moving to that world, but however, now, as you said, that we need to think about the asset performance, opposite register, the GIS, all of the real data that we have and how we as human analyze this in order to act and having better measurement and better quality of service delivery. Right, this will bring us to the next presentation. Next presentation will be delivered by Josh Elliott. Yeah, so welcome to the stage.
Good morning, everyone. This is high enough. Yeah, good morning, everyone. Quite some presentations to follow. I think what we'll end up doing in this session is probably layering over some of the concepts and the conversations that have already been had. And I think what we'll try and do here is pivot slightly to how FIDO is using the technology, but also trying to mobilize some more sort of catalytic communities around how we actually get some of this done between both the public and the private sector. I'll try and draw on some examples from around the world and the programs that we're working on. In particular, I'll dive into one with Thames Water, which I know some colleagues in this room have also already had some experience with in the past. I'm also looking at the time and realizing that I'm the only man that stands between you and your next coffee, so I will try and do my best. Is this working? I've really got to press it. No. No. We're talking about technology problems here. No. They've gone for coffee already, yeah, exactly.
Anyone from IT to support? Or the guys there with the control? 4%. Can start talking to you. Can start talking to you. Okay. There's technical problems, so that's what we need to
Okay, there's a technical problem apparently. It's quite technology. I'll in the meantime, I'll give you a quick overview of Fido, if for those of you who haven't come across the company before. So we're a UK-based company just outside Oxford, focused on acoustic technology and using AI to understand data. I'm talking about data, and be careful how I talk about data based on the previous presentation, but yeah, we're using it to create sort of a very sort of immediate, scalable, and very adoptable approach. I think there's a tendency sometimes with technology organizations, and I've worked across various different industries before, although I'm only just past 28 years on this planet, so I think I probably don't have as wider experience as other people, but some of the things that I have learned is that, especially with software, in particular, you need to make it incredibly user-friendly and reduce the amount of stickiness or friction that's actually required to sort of make some of these programs work. So one thing that I will sort of pull on if we ever get to the presentation, in which case you might just have to hear me talk for 10 minutes, which is a shame because there's some reasonably nice slides on there, is this reducing the friction in which it takes to sort of combine efforts in different forms of technology. So let's keep moving forward. So without the slides, it's going to be a little bit difficult to explain some of this, but I think a central tenet to how Fido operates is between the use of both hardware, machine learning, but also the ease and adoption of the technology and the hardware around the world. We effectively have a methodology which is focused around ease of deployment, and this involves sensors, very small acoustic microphones being deployed onto the network. Oh, here we go. We're alive again. Right, let's go. Okay, back to it. So yeah, so what we're saying is that the sensors get deployed out onto the network. They take acoustic readings. Those acoustic readings in particular areas, I realize DMAs, from the sounds of things, are very difficult here, but typically we'd have a deployment area. Our AI would also optimize a optimal deployment layer, which would give the deployment team the ability to know with more degree of accuracy where, based on the pressure data and the flow data and the GIS, if it's available, where the optimal locations are for those sensors. Those hidden leaks are detected within within 5 seconds. Really, it takes a reading, it takes a scan from the pipe, so we can do effectively a lift and shift model. So that means that you can cover vast areas of network quite quickly, and it also doesn't necessarily need at this stage to have particularly qualified or technical engineers. When you get down to sort of further down the line, when you're doing the analysis of the acoustics, it obviously requires more like sensor technicians and sort of leakage engineers around that way. But there's a key reason for that, is that often in the regions and the countries that we operate around the world, is that you are also coming across the requirement for a socioeconomic upskilling as well. It's not just a case of chucking sensors out to already qualified engineers or already qualified teams from the UK. It's about democratizing access to a lot of the technology as well. So that's a core function and a core design principle actually in how the technology and the hardware has been designed. As I go on to say, sort of the leaks are then sort of geolocated and sized, much like some of the other technologies, I believe, that we've heard about over the past couple of days. But what this does do is all around the intent to work smarter and not harder, I suppose, and that's allowing municipalities and later sort of corporates, which I'll talk about, to focus the intent of their investment in very specific ways, rather than sort of wasting time and money in areas or zones which are not going to yield the best return on investment. The sensors, sort of finally, the sensors are non-intrusive, so these do just sort of magnetically sort of work with both metal and plastic pipes, and they stick externally, so there's no need for any sort of intrusive elements there. Oh, go back. As I said, sort of a little bit about the global footprint. The keen observers amongst you will notice that there is no presence in Oman, and that's about the extent of my sales pitch for today. But we do have, and sort of drawing on Lloyd's map of water stress regions from around the world, see an extreme pressure at the moment in countries for different reasons, I think, is probably the best way of describing it. For example, South Africa is a particular hotspot for us. Johannesburg experiences incredible water losses. I think layered on top of that, you've got the geopolitical context as well, and the socioeconomic challenges that are faced in that region makes it an incredibly hot topic, but also particularly difficult sometimes to operate in those countries. And then if we sort of flip to another example, which is, according to the Gartner data, is not, the most stressed region, but if we take the USA, for example, what we're seeing there is big efforts economically and geopolitically to draw or to reshore a lot of the manufacturing of critical minerals and critical assets. So we're experiencing interest from the likes of data centers and semiconductor businesses who are trying to sort of talk about de-risk or de-escalate their exposure to certain parts of the world where you have geopolitical tension. The challenge with that is that the key areas that we're focused on within the US, especially across areas like the Colorado River Basin, also face extreme environmental challenges with water pressures and water stress. Layer in then the challenges that are faced if you are not able to draw multinationals into those areas for job creation and GDP and prosperity. You have a real challenge as a utility and a wider authority if you're not able to draw multinationals into those organizations down to an operational risk based on water resilience. So we see different challenges in different parts of the world. And India, equally phenomenally ambitious in their goals to reduce non-revenue water, again for economic prosperity and socio-economic development. It's a big part of FIDO's approach, actually, to sort of make sure that however that technology gets in, or our technology gets embedded into those regions, that there is a key sort of upskilling and educational element. Because if we're talking about, the title of this, or the hypothesis of this discussion is around creating a scalable model for non-revenue water reduction, there has to be a slightly different way of doing this. And our view is a lot of that can be empowered to the end user, which doesn't necessarily have to be technical to begin with, to enable them to participate and have the whole process democratized. So it's interesting. It's gaining traction. Equally, other parts of the world around here, we could talk about talk about this to the end of the world, about why they're water stressed and the challenges that they face. But I thought I'd just give it a little visual representation. So onto the actual model. How does this actually work? So we've talked a lot about, and I think we will have heard over the past couple of days, this notion of public-private partnerships and actually how that actually manifests. So Victoria and Neil, the founders of FIDO, took a particularly keen interest in understanding how we can mobilize corporates, some of them listed on the screen here, to create a mutually beneficial outcome for both the utilities and the municipalities, but also the corporates and the regions in which they operate. So we all know that Microsoft, Coca-Cola, Meta, they all have sustainability targets and ESG goals now. A big part of that relies on water replenishment programs. So what FIDO decided is that, combined with the challenges that the municipalities face, is that we could create this sort of blended community in between, whereby there is a focus on corporates achieving their sustainability targets, which are of course publicly listed to shareholders and the wider public. But also the requirement that they have, speaking practically around operational resilience within the regions in which they operate. So Coca-Cola and their bottling plants within Mexico in particular are facing extreme water shortages. The real impact is that it has an impact on the bottom line of the business, rather than necessarily all about being the sustainability credentials. But what we are seeing is that the appetite, once these programs get going, there's a very, very fluid transition between the teams within the corporates and the desire to work with municipalities around the world. So it's effectively balancing some of that budget deficit, which especially some of the European nations faced within their public authorities, to take and mobilize corporate sector money to create, as listed here, very immediate, localized, auditable performance effectively against the budget in the in the utility, but also the sustainability reports and the sustainability requirements of the corporates. So a little bit about the data. I'm not going to dive in too much because I feel like I might be shot down at some point with talking about data quality and things. But high-level stats on this one. Thames Water, which I know sort of colleagues in here have worked with before in the past. Very successful program for FIDO so far. 628 million gallons of water in year one, which is about 189% performance against their leakage targets. I think we're actually on track for year two to produce just over 200% against the target as well, which has carbon savings and things like that. But what the point of this is that the partnership between Microsoft and Thames Water has proved very fruitful. And what we're seeing is, to my previous points, we're seeing a sort of an operational de-risking within the region that Microsoft's operating in London, but also this appetite for scaling this sort of behavioral change that Microsoft and utilities have around the world to now transcend into places like Phoenix in Arizona, Querétaro in Mexico, and Las Vegas. And the common theme amongst all of those is an element of technology in the middle and making the technology accessible, usable, and trustworthy to a greater or lesser extent. And that doesn't mean that there's been plain sailing at all along the way. FIDO is only about 6 years old now, so it's had incredible learning curve. I've been with the company for just over 15 months now, and I don't know if anyone's worked in a startup or a scale-up before, but it's absolutely rapid change. You learn and fail very quickly, which is always interesting. So, great lessons to be learned from Microsoft. FIDO is also listed in their 2024 sustainability report. So, if you'd like to learn a little bit more about that, please take a look at their sustainability report. I'd be happy to talk about it afterwards. Working towards the end here, I think the point of this slide is really to just draw out the fact that this isn't done in isolation. Anything related to sort of quantitative and data and reporting, and especially ESG metrics that go into sustainability reports and annual reports for the utilities requires an element of independent validation as well. So our results are audited effectively by Limnitech and Blue Risk, which means that the results that come out of those projects have a very, very high degree of trust and reliability. So at the end of all of this, the aggregate and compounding effect of the projects that we're working on and the projects that people in this room are working on have to land in a place where it's trusted and it's verifiable and it's auditable in order to see progress, and also to be able to say, from a narrative perspective, that there's the positive momentum behind some of these changes. I think sometimes there's an element which is missed in these sort of programs, which is a sort of an art in the storytelling of what's actually going on with the programs. I mean, we've heard of some very major transformational changes, especially with some of the projects going on in the country here, and I think there's always an element of being able to tell those stories in beautiful ways, as the previous speakers have done. And finally, I think, because I'm almost on time, the point of this is to sort of indicate that sort of we are a growing technology company now, focused in non-revenue water and AI. The focus for us is in the data, dare I say it, and the unity of hardware and software and apps and things like that actually also sort of, to a greater extent, informs this behavioral change in society as well. So plenty of people are digitally native now. Plenty of people especially in water-stressed and less developed nations around the world have access to a smartphone. It's not a big thing anymore. So what we're trying to do is now, along with the FIDO Plus communities that are being mobilized, for example, Water United, which is based in the Colorado River Basin, is also adapt the way that we deliver our technology as well, because it's also recognized, if you take any leading technology company around the world, there's a very, very high degree of self-serve. I think you'll never get to a point, in my opinion, where technology and human intervention or human interpretation are devoid of each other. Absolutely required. But I think in terms of putting forward a new model to help scale the challenge around non-revenue water, what FIDO is now doing is using what we're calling FIDO Smart, which is a delivery of the whole package, effectively, in sort of in terms of the sense of the app and the AI, at least to generate the momentum and the traction around visibility on leaks and actually where are they, what's going on, how are the networks behaving, which is a place where especially AI and a combination of techniques which have already been listed, I think have a place to play, and this is an emphasis for us, especially on water stressed regions around the world that aren't necessarily the US and the UK, to decentralize the technology that FIDO has a little bit and give it and empower communities on the ground. And that's me. Thank you very much. It's been a pleasure being here today.
Thanks, Josh, for this insightful presentation, which is taking us deep to the integration between the applications and the fieldwork. Right, we are leading to the last presentation. As I told you at the beginning, we are lucky today. We have 7 presentations. So the last presentation will be delivered by Engineer Saeed Al-Busaidi. Saeed, he is the Asset Performance Manager. He will talk about the pipeline rehabilitation.
Assalamu warahmatullahi wabarakatuh. Good morning, everyone. My name is Saeed Al-Busaidi, Asset Performance Manager from Oman Water. I will talk about AI used in pipe rehabilitation. We are lucky today. We are talking at the same topic since the morning. I think all here we agreed with the same thing. We are aligned with the same target. I remember a few years back that when we talk about AI, machine learning, the utilities or the customer, the end customer, start thinking or raising a question, do we really need it? Are we mature enough to use it? But nowadays we can see, since morning we are talking about AI and we can see a great benefit from it, and really it's can save a lot of time and money. And last year, we took a decision to develop one of our strategic projects or program for asset rehabilitations or pipeline rehabilitations, and this is part of Sustainable Water Resource Management framework. And then we implement the AI, and really it was very nice story or experience, and this is why I'm here to share it with you. And this is a continue what Engineer Khalil talking about. It's part of NRW program. So my presentation, it's very short. I keep it. I know I will be at the end. So we'll talk about the challenge objectives, machine learning analysis we use, the packaging and prioritization using the AI, then the conclusion where we will see some results from the projects. Again, data quality. I don't know the guy, but data risk, we can say it. I like it. But not only in our company or utility, it's all over the world. Data is the most important thing. This is the foundation for any analysis or any programs. So data was the challenge we face, as also presented in the second presentation. But we did a lot of cleansing, and we use AI to get some information. If the information is missing, we will search around and try to collect the nearest information and building our program. The scale of analysis, if you see the map, as an Oman Water, we cover mostly 10 regions except Dhofar, and we have as mentioned, more than 25,000 kilometers of pipelines with different material, different sizes, in different locations, and we have different topography in Oman, so it's quite challenging to do analysis for whole the system or the network. Then targeting the high risk and aging pipes. We have another challenge that we have old pipe with a lot of burst, and also we have young pipe with a lot burst. So to balance between the risk and age is also a challenge. Sometimes you cannot do it in manually, I can say it, but you can do it maybe with machine learning or AI. The resource constraint, of course, budget. Everyone here, they will think in budget twice, because it's quite expensive in our country to replace many pipes, especially in some location near to the mountain or crossing wadis or some difficult areas. And at the end, quantify the failure risk. We have a lot of failure in last 2 years, and we need a solution from AI or machine learning to predict the future. We need to see within replacement the pipes how we can also predict the future leakages. And if you see the top of the map, and it's mentioned with Khalil, the NRW reached 40%, around 40%, and the number of leakage on 2023, it's more than 140K or 1,000, and mainly in service connection. I can say 75% in service connections. So the objective of this project is to address these challenges and to use the AI machine learning to do analysis and predict the future failures. Also ensure optimum data-driven decision making, and to have a clear roadmap for rehabilitation plan and the budget, because we need at the end of the day to submit it to the regulator to get funding. Also, we have some small objectives to define the criticality, the risk of the pipe, which one need to have a protections or need more attentions. And at the end, we need to allocate the budget, calculate the ROI, return on investment, and so on. We use for this project the Optomatics software from Suez. Yesterday, there is a presentation from Suez. Mr. Ben already discussed or talk about the machine learning and the type of machine learnings. So we will start from machine learning. At the first stage, we use the machine learning to collect and analyze the data. The data is coming from GIS as main data, and then the burst from operation records. We use the hydraulic modeling to understand the pressure on our networks. Also, we use some open sources to take some soil and geographical locations informations. All these putting in the machine learning and start doing the analysis. Then we did LOF, likelihood of failure, and COF, the consequence of failure, so we can see the risk of the pipelines. Of course, at the end, we define the hydraulical and business criticality assessment. From this component, we came with different scenarios, and we choose the optimum scenarios from the machine learning. If you see, here it's a little bit in details. We use 80% of the data to train the data set in the machine learning, and the 20% for testing and validation. Also, we add some factors, because here we have a request to monitor or to focus on the pipe which is crossing the wadi, because many pipes was washing out recently during the heavy rains. And we'll come to the results of the machine learning. It was very interesting to see the results. If you see in the bottom left side, the data was from, for training purpose, we take from 2017 to 2021, and from 21 to 22 was the testing and validation for the machine learning. And if you see the blue line, it's very clear that the result, it's almost align or matching the number of failures, and we believe that we can predict and we can do forecasting. If we see the variable impact, we can see that the burst or past burst is more variable impact, or I can say it's a more sensitive one for our study or analysis, then the age, then the maximum pressure. These three, it was playing the big role on the analysis. And if you see the table here, it's the important one where we can see the number or the accumulative pipelines and how much associate with burst. So we found that 1.5% of accumulative pipelines is associated with 39%. And if we go to 2%, we will see 46. And if you take 5%, is 60. What does that mean? It means that if we'd like to put a target for us to reduce the number of bursts, then we can understand how much pipeline we need to replace. Because if we replace 2% of our pipeline, then we can reduce the risk or the burst by 46 or nearly to 50. So this is a good approach that it gives us a little bit of confidence how we can estimate the number or the percentage of pipeline replacement, and then how much budget we need to associate. And if we need to...
Maybe he's out. And let us start by taking the first question.
Hi, everyone. Thank you for the fruitful information. And it's really interesting how AI changed our life. I want to ask about monitoring, which is the first step in order to analyze and to have the conclusion of converting data into AI and optimization system. So the first step is the monitoring or the hardware. So what is the best or reliable hardware for the monitoring system? And you use, this question is for Mr. Khalil, you use different types of monitoring or analyzers. Honest answer, what is the best reliable monitoring hardware you used for accurate monitoring or accurate results?
Thank you for the question. I think we test many things that to detect the leaks. It is not just only, maybe when NAMA, we put just only one section for initiative things. We are trying to do a lot of things. Maybe the best way which we are using now, we bring the leakage system that we are using NetBase. NetBase, it is one of the software that you can integrate anything there in matter of the SCADA, billing system, and everything. This is, I think, what you.
But I think he's talking about the hardware, not software. It's not a computer, right? He's talking about, you are talking about the hardware, right? Yeah, so it means you are using normal computers, I guess.
Yes. For the equipments.
The acoustic system or the pressure system or the dry pipe system, which one is from your
I think the best way, it is active leak detection, using the leak detection equipment, the acoustic equipment. And also, you cannot ignore the others, like pressure measurements, also one of the tools that will drive you that to reduce the losses, and also the repetition. So all of them, it is, you cannot say it is one tool you need it. You need to implement everything. So you need to do leak detection by using the best, the newest technology, like acoustic equipments, because you need to, for example, to detect the leaks in the surface connection by using acoustic equipment, ground microphone, listening stick. And also, if you are going to do investigation for the main lines, you need to do it colorator. Also, if you are going to do it we have one of the technologies, satellite leak detection, and this help us to speed up our survey for the DMS itself. So all of them, this technology, it will help you or to support you to drive yourself faster to that area.
Thank you. Next question.
I think, I don't know, microphone works? Yeah. Well, we tested all those technologies in our project, and of course, in my presentation there was let's say the winners of the different technologies that we tested, and for sure, yeah, they all work. Sometimes they require certain conditions to perform well, but we found that for the distribution networks, of course, those zone scan correlators were very functional in combination with AI to send the teams to the right location, so they don't have to do the whole DMA, for example. And yeah, for each application there is something else. For main trunks, of course, you need different equipment again. So if you want to know a lot of details, you need to visit the stand from Blue Gold Technologies. They are there. They know more about it.
If I may add, it's not only about the equipment that we are going to use, but also the communication system that we are going to use, if it works, if it's adapted for that sensor. And again, the human part, because the equipment needs to be installed. So we need to be sure that it's properly installed in the right place to do the proper function. So it's a lot of variables that affect the right equipment to be used.
Thank you.
Thank you.
This is Dr. Aad, Water Distribution Directorate from IWA Bahrain. My question to Mr. Nono, I think you have indicated in your presentation that you could reach to, I'm not really sure, 23% to 63% related to the fraud cases, the illegal cases, subjected to providing correct input or correct data. So my question is, what kind of input data is required for you to reach to this target? And if those data were provided, would you commit reaching such target?
The 63% was about the precision of the results of the list to be visited. So from what it has came out from the fraud seeker, a list of 100, for instance, 100 possible frauds. In one of the cases, we reached 66% of precision. So 66% were frauds. It doesn't mean that we had 66% of fraud from all the billing. And the most important is to be sure that we are collecting, we are not working with estimations, with the real readings. We have precise readings, and all the metering system is working properly.
Sorry, I'll just repeat my point. So we're not committing reaching any targets by using the AI machine that you're providing, right?
I'm not committing with the target. These are the results that we have obtained in 4 systems. So one, and the more time you stay, because in fact, depending on the area that you are working, even in the same city, you have areas with different behaviors. So you will have results different from the several areas. And the more time you start collecting this information and uploading in the algorithm, you will be able to reach better results. Not all were with 60%. One, it was 28, or I believe.
Right. Thank you. Thank you so much.
Okay, please.
Hi, I'm Vijay from L&T, and thanks for the very informative presentation. And this is a question to any one of you, because it's a common question. There has been a lot of discussion about asset health monitoring, using the information and using the recent techniques that AI particularly. A lot of emphasis on how accurate the AI predictions have been. What are the steps you think are necessary to ascertain the sensor health monitoring system as well, in addition to the asset health monitoring? Because finally, the decision is made on information derived from the sensor. So what are your takes on that?
If I kick off on that one, I'll give it a go. And you're from L&T? Yes. Yeah, I used to work with L&T many years ago, probably about 25, 26 years ago. Nice to see you. Yeah, so sensor health. There's a lot of sensor tech out there now that will self-monitor. I think that's what you're asking. That needs to be really carefully understood as to what it's actually doing in its own algorithms and its own health monitoring. Because for a lot of my colleagues here, we need to understand what it's telling you is unhealthy or healthy so that we can actually believe in it and have confidence in it. So that requires some quite detailed discussions between the sensor manufacturers and the systems integrator and the people that are developing and deploying these AI solutions to really understand that. There's a tendency with technology to just send you a signal saying, I'm healthy, and then if you don't get that signal, you're not healthy. Well, I'm not really sure that really helps us. I think we want to understand the detail in it and then link that detail back up to our overall health algorithms. I don't know if anyone else wants to add anything to that, but that'd be my take on it.
Yeah, maybe I can add here something from our experience. Normally when we talk about asset condition or health, we sometimes differentiate between two things. Operational health, how this asset is operated, is it in right place as a design, or it's pushing up far away from what it's designed for. And there is another part where we call it physical condition. Is it in right physical conditions or it's not? So there is two parts. And the AI, what I can see now from AI, it's focusing more in operational condition of the assets and can do a lot of analysis, even can predict the future failures in that assets.
Right, many thanks, Said, for the answer. I think by this we cannot take more questions. We apologize for that as we are almost today. Yes, you have something? After that, if you don't mind, or because we have a coffee break and we have another session number 5 coming soon. So thank you very much for being with us. Now I think we have to take a group picture for the session.
Thank you so much.
Thank you.
Thank you, Dr. Zahran, for this excellent moderation. We invite you all to have a group photo. Then we invite Dr. Zahran to give our speakers appreciation certificate. And for all, we will have a 15 minutes break. Then we will back for the 5th session. Starting with Nuno Marquez. Michael Bertveld. Simon L.A. Engineer Khalil Al-Adawi. I think we are missing Lloyd, so Josh Elliott. Josh Elliott, yes. And Saeed Al-Busaidi. Thank you all. See you after 15 minutes. We will start the 5th session, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you for coming. We will start session 5, Innovation in Wastewater Treatment. It will be chaired by Dr. Saoud Al-Durraiz, General Manager, Water Desalination Technologies Institute, Cascade. Please.
بسم الله والصلاة والسلام على رسول الله. السلام عليكم. صباح الخير جميعا. Good morning everybody. Welcome to session 5, Innovation in Wastewater Treatment at Oman Water Week. I am Saoud Al-Durraiz and honored to chair this session. In this session we have 6 distinguished speakers who will share their innovative solutions and research. With the growing and pressing challenges on climate change, urbanization, and resource management, this session focuses on latest advancements in wastewater, or improving the wastewater or treatment efficiency, effluent quality, and sustainability. As you know, there will be dedicated time for question and answer at the end of the session. So please feel free to write down any comment or questions for our speakers during their presentations. Now it's my pleasure to introduce our first speaker, Dr. Engineer Ihsan Mohammed Bajo, Process Development Manager at Jaeger Envirotech. Dr. Bajo specializes in biological wastewater treatment and irrigation technology. He and his team developed the ShareCon process, which enhanced treatment efficiency by transforming conventional biomass into premium biomass without chemicals. His presentation title is ShareCon Process, a comprehensive solution for increasing treatment capacity, effluent quality, and energy efficiency in municipal wastewater treatment plants. Please join me in welcoming Dr. Bajo.
As you probably read the topic, it's about how you can increase the treatment capacity of the wastewater treatment plant and achieve a better effluent quality, and also increase your energy efficiency in wastewater treatment plant. I think that is one of the critical topics nowadays, that many wastewater treatment plants receives more wastewater than they are supposed to do. And with our technology, the ShareCon process, you'll be able to enhance the performance of your wastewater treatment plant. So maybe a very short background about the company. So Jaeger Umwelttechnik, or Jaeger Envirotech, is the small to mid-sized company with around 1,300 employees. It's based in Hanover, and it's well known for its diffuser technology. They developed the first tubular diffuser, I think, about 87 years ago. And apart from that, we have also developed new technologies like the endless tube, which has multiple applications for pond aeration, for wind turbine, for desalination to avoid jellyfish, and so on. But the second main product that we have is our fixed bed biofilm technology. You can see on the left side. I can explain more in detail later on. But these are basically a very simple technique to increase the treatment capacity of the wastewater treatment plant. So operator does not need to learn something new. They just bring extra biomass in their system by incorporating these modules. As you can see, they can provide more surface area, and then it accommodates bacteria. And apart from that, we can basically do the design from the scratch. So we follow the German standard, ATV 131. And then we can say, based on your condition, the wastewater characteristic, wastewater temperature, required sludge retention time, and so on, how much biomass you need in your system. And then we have the substrate removal rate and so on from our technology, and then we can do the design. In certain large projects, there might be need for simulation so that the operator get a peace of mind of how the wastewater treatment plants will react under different conditions. And we can do the simulation. And apart from that, the values that we incorporate in our simulation and also in our design is what we do sometimes with the university, because if we say that, for example, the value is good, it is not good enough, the customer may not believe, and sometimes universities act as an extern to do that test, and then it is sometimes considered even more valid. So that is how we basically proceed with the design. Maybe a very short introduction about the biology. So basically, if you go to any wastewater treatment plants, the heart of the wastewater treatment plant, it's biology. So you can see that it always looks like brownish in color, and this is a combination of the wastewater which contains contaminant. We call it substrate because it's food for bacteria, as well as the bacteria and the water being treated, and that's why it looks like this. And it's called MLSS, mixed liquor suspended solid, activated sludge, which is a sludge which is active, or biomass. So they are all synonym. How this concept was developed, this is something that we as a human being copied from nature. So not we, it's basically old technology. It is more than 100 years old. So if you basically go to the river, it is always advised not to drink the water from the river because it seems to be clear, but there are always certain concentration of bacteria in the river. And if you basically drink it, you get sick. But some of those bacteria are really beneficial if you create different environmental conditions. They can basically treat the wastewater. And that is how the concept of mixed liquor suspended solids application was developed, that you can see that these brownish bacteria here are the ones who treat the wastewater, and basically you have to allow them to settle, and then the clear part is the treated water where you can discharge. That's why in any wastewater treatment plant, you always see large clarifiers, and this fulfills this role that it allows the bacteria who treated the wastewater to settle, and then you can discharge the treated water. Problem is, there is always a limit. So when you get more wastewater, you have to have more bacteria in your system. To visualize this better, it's like if you give me, for example, one pizza, I can eat it. If you give me 2 pizza, I may not be able to eat it, so I need another person beside me to eat that. And this is exactly the thing that happens in a wastewater treatment plant. So those wastewater are contaminant, but they are substrate or food for bacteria. And if you have more food, then you need more bacteria to do that. And what you can do is that you can copy the other thing that happens from the nature. And that is basically, if you go, for example, to the river with the barefoot and then you touch a stone, you can see that it is slippery. And this is basically the biofilm formation. And this is how the concept of trickling filter was developed in the past. Problem is, the stone has limited surface area, so you can have limited concentration of the biofilm in your system. So as an alternative, you can basically use a biocarrier. Biocarrier has more surface area, and it acts like a condominium for biomass. So it allows you to accommodate higher concentration of the biomass in the system. We basically offer 2 different kinds of biocarrier, known as a biotextile and biocarriers. They have different surface area. Installation in this way is that basically if there is an existing aeration grid, you can put these cages in the existing on top of existing aeration grid, and then you can be able to bring more biomass in your system. Sometimes in certain projects, there are, for example, old oxidation ditches, and it's not only the matter of bringing more biomass in your system, but also you need to increase the energy efficiency. And there you can couple, for example, the biocarrier with the microbubble aeration system. You can see that on the right side, this kind of diffuser is very energy efficient. So its lifespan is around at least 10 years. And when the lifespan is achieved, you can basically remove the membrane and then put a new membrane on top, so the reinvestment cost is less. But the advantage is that the SOTE value is very high. Basically, at the low airflow rate, the SOTE value is around 9% per meter. Conventional diffuser have around 5.5 to 6.5%. So this means that incorporating these modules with a highly efficient diffuser, you'll be able to increase the energy efficiency in your system. And apart from that, this technology can be operated at the DO level of about 1.6 up to about 2 milligram per liter, which even reduces the operation cost in the wastewater treatment plant. What is interesting, I would like to basically share with you is that about 5 years ago, we were analyzing the data. So data analysis became more and more popular. So we started to investigate some of the data from the Cleartech plant in the UK, in Tunisia, in Germany, and in the US. And what we found was that some of those plants were treating more wastewater that they are supposed to treat. And there are always some safety factor, but we reached to the point that it did not make sense. So the amount was really more than it was supposed to. And we decided to actually put a pilot plant in the wastewater treatment plant of the city of Hildesheim. It's located near to the Hanover. And we wanted to measure the nitrification rate of the biofilm, conventional biomass from the activated sludge plant, and also the suspended solid from our system. So you can see on the right side, if you consider the nitrification rate from 0 up to about 140, you can see that the biofilm itself, it does nitrify. So the nitrification rate is around 30 milligram N per gram TS. You have some diffusion limitation and different zones. So sometimes aerobic, anoxic, and anaerobic zone. You can't avoid it. They're always there. Suspended solid from the conventional wastewater treatment plants. The nitrification is around 55 to 65. You can see this blue color. And then by our technology, it was about 80 to 90 milligram N per gram TS. And there we did not do anything. So basically the cages were there. And then we noticed that the nitrification rate of the suspended solid from our technology is better. So basically we realized that in the nature, there is actually another fraction which happens randomly, and this is called detached biomass. Certain technology provider, they do that also. Like for example, by MBR, you always need to keep the flux so you have a good sloughing rate. But basically, if you harvest that biomass at the right time, you will be able to utilize its property. And two of those properties that I want to give as an example are higher nitrification rate and better settling velocity. So over the past 5 years, we did a lot of investigation and we patented the ShareCom process where we basically harvest the biofilm in a way that we want. So you have to have a right diffuser type, diffuser density, right specific airflow rate, and the right harvesting time. And these are two examples that you can see that. And below is actually the fish analysis. You can see how you can increase the ammonium oxidizing bacteria and nitrate oxidizing bacteria by having a right sloughing time. And the nitrification rate can be between 80 to about 145 milligram N per gram TS, which is almost twice as much as the nitrification rate of a suspended solid from the conventional wastewater treatment plant. If you basically harvest it in another specific time, you will be able to reduce the settling velocity of the sludge. You can see on the left side is a 5-minute settling velocity of the sludge from conventional wastewater treatment plant. On the right side is a settling velocity of the sludge from the ShareCom process. I won't get into the detail, but basically these are two case studies. You can have a look at the effluent quality, which are always critical. You can see that the COD is typically in the outlet around 20 milligram per liter, BOD5 about 1.5, and the ammonium is between 0.3 to 1.5. The main difference is that in the summertime, the bacteria are more active, so you typically get a slightly better result for ammonium removal, so 0.3. And the wintertime, it's around 1.2 milligram per liter, which is also still a good result. Another example is the wastewater treatment plant of Weissenbund, and there the ammonium concentration is also around 1.3 milligram per liter. The other thing which is interesting is sludge volume index, SVI. So SVI shows how good your sludge settles. If your sludge settles very well and your plant is being operated in a good condition, you don't have problem with filamentous bacteria and so on, you will be able to reduce the SVI significantly. And in these two plants, you can see that the SVI in the first one, Weissenbund, was reduced from 126 to about 68, so almost half. And the second one, Geisel-Bulach, it was reduced from about 200 to about 80. And the second one, for example, is running the aeration tank with the MLSS concentration of around 5.5 to 6.5 kilogram per meter cube, which is a typical concentration for sequencing batch reactor, but this plant is a continuous flow. I can show you a very short movie about this plant. So as mentioned earlier, this is called Geisel-Bulach. It's located near to the Munich, and it's a 240,000 PE population equivalent. Here is the aeration tank. You can see that it is not over-aerated. As mentioned earlier, the DO lies within 1.4 to about 2 milligram per liter, but most of the time around 1.7. You can see that we take 1 liter of sample into mesh cylinder, the graduate cylinder, and then you can see that within 5 minutes, most of the sludge settles. So basically, this was the information I wanted to share with you in this presentation. If there is any question, I'm looking forward to answer your question. And also, we cooperate closely with the university, so if there is a potential for cooperation, you're welcome to discuss this as well. So thank you very much for your time, and
Thank you, Dr. Bajo, for being on time and for this insightful presentation. Our next speaker is Dr. Naama Sharif, Regional Manager, Water Engineering and Business at Brentford, Europe. Dr. Sharif has over 20 years of experience in wastewater treatment, sludge management, and biofilm technologies. She has worked extensively in the German water sector and MENA region on wastewater projects and policies. Dr. Sharif will present a novel IFAS system for treatment of municipal and industrial wastewater. Please welcome Dr. Naama Sharif.
Good morning, everybody. It's my pleasure to be today with you to present Brentwood Company. Brentwood headquarters is in Pennsylvania, and my office, where I am working, based in Germany. I would like to present IFAS system application in municipal and industrial wastewater, and I am very happy because the presentation before was in the same family of the IFAS technology. So I would like to go through biofilm system, then about IFAS application, and I would like to say that IFAS is integrated fixed film activated sludge, and EcoFAS is our IFAS, as is Brentwood IFAS. And sorry for my voice because I have allergy against dry weather. Then I will go to some concentration about design and process treatment, and finally I'll go through some successful case study for Brentwood worldwide in IFAS application in municipal and industrial wastewater treatment. So biofilm system, it's the same family what Dr. Ahsan talked about, and this means that the treatment, wastewater treatment performance depends on attached bacteria and on the filter media. And in our case, the filter media is plastic media. In Dr. Ahsan's case, it was different supports media. So as you say, biofilm is 3 phases. Water and air and also biomass, and the idea behind this technology is to create a large contact surface between the bacteria and wastewater, and this means increase the treatment efficiency and the capacity of the wastewater treatment. So why the idea behind IFAS, it was just to overcome some challenges faced activated sludge system like high loading, and sometimes we have old wastewater treatment plants or overloaded, so and no chance to make more expansion. So we have to create high efficiency in the same volume, so IFAS can do this. So also there's many benefit for IFAS application. Indeed, it's improve the aeration, improve the treatment efficiency, reduction of POD, improve the nitrification because it's just biological and aerobic system. Also, I saw the very good example for a presentation of Dr. Ahsan about the sludge quality. So this means a lot in wastewater treatment plants because this increase the efficiency of sedimentation tank after biological treatment. So as you see, it's very similar to activated sludge system. So IFAS is activated sludge system, but we put inside of the aeration tank our media, which is plastic media. So in this case, we can operate it in two cases, with or without return sludge. Also, in this case, we have two kinds of bacteria suspended and attached working together. And we can also achieve more than 50% from the treatment efficiency, more than activated sludge system sometimes. So the application of IFAS is for, it can be for BOD reduction alone, or for BOD and nitrification, also with or without return sludge, and also we can implement it for tertiary treatment. So what happened in aeration tank? The media is inside. So in this case, as I said, we have two kinds of bacteria, suspended and attached. Normally suspended working on BOD reduction, attached working on nitrification. And the culture of biofilm itself protects the bacteria from toxic material and makes more efficiency in nitrification. And yeah, in this case, we can achieve more efficiency and more optimization in aeration. Because we can, in this case, we can use fine bubbles. It means saving energy. So Brentwood produce also filter media itself. So we have PVC, different design and different structure. We have also from polypropylene. And I would like to show you the innovation. So the innovation in design of the media itself, and also how you put it in the aeration tank. So in this case, the aeration system is in the bottom. We put the gross flow media, then the vertical flow media, and the gross flow media works like a distribution for the air. So this makes optimization of aeration, and this means a lot by operation. If you see the red line, when we use distribution media, so the distribution of air is optimal in the whole tank, but in case we have no media, so the aeration is not optimal, and this affects the treatment efficiency itself. Okay. I would like to come to the first case study in Pennsylvania. So this was food industry wastewater, and it has high load BOD and nitrification. And the problem was the nitrification efficiency was low. The concept was just to put our media in this nitrification tank, and this makes the nitrification from 7.5 in outlet to 4 milligram per liter in outlet. So this is the green line before the implementation of IFAS, and after you see how it improves the nitrification, because you know nitrification is not easy to remove. Scholven wastewater treatment plant, it's also industrial wastewater treatment plant in Germany, and with the time it was overloaded, and there's no space to make more tanks. So the concept here, just to use the same tanks, just we switch the system from activated sludge system to IFAS system, and just put the media in BOD reduction and in nitrification, and we use also lamella settler to improve the sedimentation quality. There's here, but no return sludge, so we use also our media in nitrification and C stage, and this was the solution. This is from Tunisia. This was also Biolot project. Compact unit for small wastewater treatment plant in Tunisia. This compact unit was tested in Germany and delivered to the location there, and the solution was also IFAS or FBBR here, putting also our media in BOD reduction, nitrification. Sometimes here it's better to put sedimentation tank between BOD reduction tank and nitrification, just to remove the solids from C stage before it comes to the body of the filter in nitrification. So this makes the nitrification works in its full capacity. This is a nitrification in operation, and if you see the compact unit, it's very small. It's about 10 meter. I think the width was 7 meter, and you can transfer it from place to place, and it was also fully automatic. Because this was a research project with University of Halle, so we calculate the tanks needs in activated sludge system for the same treatment level, also by IFAS. So if you see the whole volume tanks needs by IFAS is about 50% from the activated sludge system. This means we save volume, space, energy for the same treatment quality. Finally, I would like to say that there's many advantages for IFAS. Mainly, we can go to very low BOD, to very low nitrification, to very low ammonia value in outlet. Also, it's very good in different temperature. This is all from my side. Thank you for it.
Thank you, Dr. Sharif, for this valuable presentation. The next speaker for this session is Nitil Patel, Lead Process Engineer at Veolia Water Technologies and Solutions. With 19 years of experience, Nitil specializes in membrane bioreactors, sludge densification, and industrial wastewater treatment. He has led projects across multiple industries and contribute to achieving 90% water recycling at the world's largest refinery. He will present mid-dense, combining membrane bioreactor technology and sludge densification for sustainable wastewater reuse. Please join me in welcoming Nitin Patel.
Good afternoon. Today I'm going to present on the membranes. This is innovative technology combining the membrane bioreactor with the sludge densification to achieve the sustainable wastewater reuse. This one? Yeah, thank you. Yeah, before jumping onto the membranes, let's talk a few minutes on the membrane bioreactor. Sorry. Yeah, the membrane bioreactor. So the conventional system, you can see the first flow chart on the conventional system, like a primary clarifier, bioreactor, secondary clarifier, and the media filtration. And whereas in the membrane bioreactor, the bioreactor clubbed with the membrane, so it gives retains the 100% suspended solids. So that gives the advantage of running the biological system at a higher MLSS concentration, so lower the footprint and consistent good water quality. Yeah, so it's having the MBR, membrane bioreactor process is very effective, but having a certain limitations as the MLSS is uncontrolled, complete MLSS is getting recycled from the membrane tank to the upstream of the bioreactor. So where the membranes comes in the picture, where it tailors the MLSS characteristics to unlock the potential of the MBR. So membranes reduces the operating cost by tailoring the mixed liquor characteristics to optimize membrane and the biological performance. Let's see how it does it, how it works. So basically it does with the two processes. One is a selective wasting. So basically the removal of the light so you can see that the sludge is recycled from the membrane tank to the biological upstream, and the excess sludge is wasted outside the system. So in this process, the excess sludge is passed through the hydrocyclone. So hydrocyclone, it removes separates the MLSS selectively. The light fraction goes from the upper side to the sludge dewatering system, where the underflow, the dense part of the sludge, recycle back to the upstream of the system. So basically, what we observed with the MBR system, the light fractions, which contains foulant, colloidal, and pin flocks, those are like a fouling basically for the membrane. So that helps to remove from the system. And this also the nuisance creating a foaming in the aerobic biological reactor. So that helps to remove these two parts. Where the densification, that allows to bring the good bugs, which helps to enhance the nutrient removal, and we see that it also improves the filterability of the sludge. So it helps to improve the biological portion. Sorry, go back. Yeah, this research is supported by the many other researchers, and in line with the densification impact with the MBR. Even we see the same, when it was before hydrocyclone, the TMP was on the higher side, and we were getting every 4 months, the TMP was rising and forcing to do the cleanings. And after hydrocyclone, it allows to operate more than 1 year without cleaning. Now let me go to the example real field, what we observed. So I'm talking about we implemented membranes MBR at the Detroit Lakes, USA, Minnesota. The plant capacity is 1.2 mgd, which is equivalent to 4.5 mld. The biological configuration is anaerobic, followed by anoxic and aerobic, basically to take care of the nutrient at the least possible by biologically. And the source of the effluent is the a combination of both, a 50% of the municipal and the 50% of in the industrial. And having this located in the zone, it's a low temperature, icing. So many times we see the peaks of water when the ice starts melting. We'll have a huge flow, and then variation of the hydraulic and organic loads. The TN requirement is less than 7 milligram per liter, and the total phosphorus, earlier it was 0.14 milligram per liter, and later on it was revised to 0.07. The initial first phase, it was from conventional system to the MBR, it was upgraded in the 2019. And after 4 years, it was as the TP limit was getting lowered, and utilizing the same system to treat the higher hydraulic load, it was membranes was introduced at this site. Yeah, after the membranes, we saw before the membranes, the biological flocks you can see on the left side. The bioflocks were you can see the fines and the large both combined together, where on the middle you can see the after membranes, the flock size are very clearly we can see it's the larger. Same we see in the field also when we check the a size distribution with the underflow as well as in the bioreactor. Both the size of the molecules got increased by 2 to 3 times, and that helps on the removing in the membrane bioreactor without creating any fouling. Yeah, the fouling, the colloidal fouling, so that is measured by the total organic carbon, which is less than 1.5 micron, which is prone for the membrane fouling. So after having this membrane, so we observed that the TOC also getting reduced from like a 30 to 40 ppm to like less than 10 ppm. And that helped on a longer run length between the two cleanings, so reduces cleaning, and even the operational TMP also was in a control. Yeah, the selective wasting helps to remove the filamentous bacteria, which causes a foam, and over a period it forms a heavy sludge scum layer and creates odor issues as well. So that's what you see on the other picture after the membranes. You can see the as a filamentous bacteria so removed from the system, the problem of the scum was gone. Without so the related anti-scalar, anti-foam, if it is getting dosed, that helps to reduce the chemical consumption relevant to the anti-foams. As the conventional system, we measure the always depend on the sludge volume index to assess how it will be impacted on the clarifier performance. Same in the membrane system, the time to filter, we call it. So certain amount of specific amount of the MLSS pass through the filter paper at certain vacuum level, and the time is noted down. So that's called the TTF. As the TTF is higher, the filterability is poor. And when it is the lower side, the filterability is good. So that's what we saw earlier when with the simple conventional MBR, the TTF was 150 to 250 ppm. With the MEMDES, the TTF got reduced to less than 50. And that helped on the densification. With the same, improves the biological resilience. So we check the TTF for all the three streams, basically the cyclone, upper underflow, overflow, and the membrane tank. The green one represents for the overflow. So initially you can see the delta was very high between the green and the blue one membrane tank, the TTF, and the later on, once we reached the stabilizations, it gradually reduced the window between the, for the TTF values between the membrane tank and overflow. That's the one. And the second one, during when we faced the industrial upset period, when we hit a high organic loading, only the overflow, which was going to the dewatering system, that's only we saw the spike on the TTF value, and we didn't notice much on the membrane tank TTF. So it gives a more resilience, it improves the taking a susceptibility if any upsets. It helps to do to get that shock without impacting the quality. With the same as permeability, so permeability is the flux, basically how much water is produced through the certain area of the membrane, and how much its pressure is required. So that is measured over a period of time, over continuous 2C. So initially 3 years of
advanced way of seeing it, but they learn our languages, vision when they basically watch videos and detect the faces, and when we have decision making, they use very old science of optimization, which is still quite relevant, and the modern one we call reinforcement learning. All of these algorithms fall under AI. So depending on the problem at hand, you have a big toolbox of different tools. Each of them have their own pros and cons, their capabilities, their advantages and disadvantages. So we need to understand what is the problem at hand, what are the limitations, and specifically what is the data that is available, and given these criteria, what is the right tool to use. So let's go back to water system. I'm presenting here a kind of a work that has been done by different people in literature. There's 100 different papers about this. I'm not citing anyone, but if you want, please reach out to me, then I'll send you right papers about it. So in a nutshell, we have the water system. In water system, we have operational decisions and investment decisions. The difference is that usually in operations systems, you assume assets are fixed. How do we operate them perhaps better? And when it comes to investment, the question is, how do we expand the current system, placing new piping, placing new treatment technologies, considering the mutual effects it will have on the existing system in the water sector and beyond, right? And then for that, you need to look into current networks and current technologies. Very important question here is that about technologies, there are emerging technologies. There is limited data available about them, and a lot of companies that are developing these technologies are hardly sharing data about them. last but not least, so many of these technologies, even if you have the data, even if you have the formula, if you can model them, they can be complex. I'm going to go back to that point. So when you talk about investment, you talk about long-term uncertainties. How the climate change is going to affect Oman in the next 30 years? There is no right answer for it. There are different scenarios for it. Is it going to be raining tomorrow in here? Perhaps not. But if it would be Netherlands, this is a relevant question. What is the temperature exactly tomorrow at 12 p.m. here? You may have a number, but that number can be a little bit inaccurate. That inaccuracy is called uncertainty. And these uncertainties sometimes are extremely important for decision, operational and investment decision you make. For example, if you want to know how much hydrogen you need to produce to ensure a level of supply to the customers, you need to know the demand. The question is, can we know the demand 1 week in advance accurately? Quite often the answer is not exactly. So you can't be 100% sure. So going back to the water system, it's been a tradition for 50 years that people have modeled water system using the thing on the left. They call it optimization models. You have explicit formulas, Kirchhoff's law. You have the Dicey-Weber formula, very classical hydrological models, formulas that you embed in the bigger decision optimization models. They're very nice. They're extremely accurate. Sometimes they take 10,000 years to solve. And I'm not making a joke. 10,000 years is actually the time that you need to solve them, which we don't have it. Sometimes you need decision way shorter than that. For that, you need to refer to models like reinforcement learning. They are extremely fast. They can be accurate, but they're not as accurate as their optimization counterpart. Each of them have their own advantages, disadvantages. But if you want to solve an optimization, so there's always a contemplation between accuracy and speed time. If you want to uphold the accuracy in the due time, what you need to do is to utilize auto toolboxes. For that, you can look into modern machine learning algorithms like graph neural networks and deep learning. I guess these words you may recall some of them. Graph neural networks, I don't know if you know what Google is, and they managed to reconstruct protein 3 years ago. That was a big thing in biology, and they won the Nobel Prize for this, for biology. Graph neural network was the tool they used to be able to do that. So these models have extreme capabilities. When it comes down to water, how we can use them is this. We have complex water system that has physical characteristics that makes it almost intangible to solve in due time. With these graph neural networks, deep learning algorithms, you can solve them in way, way faster time. And if 5 minutes, sure. And then last but not least, when you have uncertainty, pretty much means that you have history. You know what happened in the past. The question is what's going to happen in the future. For that, you usually use autoregressive models or deep learning models, and you project the future in terms of these green to orange color things. So future would be one realization, so that line that you see is once it happened, you know the future was that, but beforehand, future can be any line within that colorful spectrum. The question is, how would you make your decision in that regard? Okay, it's been quite theoretical, sorry for that. Let's go back to actual real world. Suppose you have a water system that includes pipes and pumps. We know variable speed pumps has a super nonlinear behavior, so we know them very well. The problem is we can't solve them that fast. And also with pipes, that beautiful formula there has a complex relationship that makes them intangible to be used in direct optimization. But the good news is that there is an artificial intelligence architecture. They call it input convex neural network. Doesn't matter what it means, what it does. The red dots there are the real profile for the pipeline. The blue dots are basically what this architecture learned from the red light. As you can see, they're hardly different. So if you would use the actual formula, this problem would never solve. If you would use this machine learning and recast it this way here, then you can solve it in less than 1 minute. That's pretty much beauty of it. Now let's go back to real world cases that is more useful. So we know that industrial plants produce a lot of waste, and those wastes are basically treated by ROs, and then the concentrate or brine concentrate is discharged in seawater. The question is, can we do something better? And the answer is perhaps yes. For example, one of the things that we look into, and I'm not claiming, first, I'm not a water engineer, I'm not claiming anything, I'm just saying what we thought and we tried. So please bear with me. what we did, we thought, okay, what if we pick electrodialysis water treatment technology that has combination of bipolar membranes and AEM, ACEMs. So we see that we have flow of concentrate in the middle, and we have the water on the both ends. Because of the separation of ions, we can beautifully basically break NaCl to acid and base. I know that the concept NaCl is a very simplistic representation. There are other minerals there, but we are going one step further to consider what the effect of those. So now, instead of just discharging the waste, we are basically treat the output of RO and produce acid and base that will be returned back to industry, and then use the remaining water for irrigation. This way, we turn a waste into two different products that we can basically create an alternative business model and make money out of it, right? There is a glitch here. The higher the concentration of the output of the RO, the lower the efficiency of the ED. So now there's the question is, what is the sweet spot for how much you should treat with RO so that your ED still remains relevant? And you see there are different points here, there are different entities, they have different needs, and finding these sweet points is a kind of a decision making that is multi-dimensional, and it's hard for one human's brain to basically come up with the answer. For a model with an AI, it takes less than a second to solve that. Yeah, so just a quick recap. For AI, you can use it for technology modeling. You can predict what's going to happen in the future, and then you can make decisions. I wanted to explain further, but we don't have time. In Aqua Connect, as I said, we have 4 use cases. We select 4 areas in the Netherlands that pretty much represent 4 extreme different environmental situations in the country and perhaps around the world. The South Holland case has quite a resemblance with Chile. We have the Amsterdam area, which is close to Bangladesh. We have Zeeland, which is close to Ho Chi Minh City. And of course, we have higher sandy soil in the west side of the country that is close to a situation in Oman and Qatar. We are in negotiation with Qatar to go and study our cases there. We have made some travel trips there, and we look forward to the same opportunity here in Oman. We think we have some solutions that we would love to see how they would perform in this country, and if they will be useful. We would love that. We are academics. We want to answer questions. And with that, I want to finalize my presentation. We are eager to learn about your problems and join you, collaborate with you in your journey towards a sustainable future. Cheers. Okay.
Thank you, Dr. Shihab, for that valuable presentation. The next speaker is Romanas Zoravlivas, Managing Director at BioRun UK. The title of his presentation is Optimization of Sludge Production at Sewage Treatment Plants and Reduction of the Associated Cost. Please welcome Mr. Romanas.
Hello, everyone. I would like to thank you all and Government of Oman and Nama Water Services for providing this opportunity to present results of our technology and for register our product with Nama. Once in a while, a new product comes along that changes everything. And today we want to share something special with you. In the past few years, our technology was implemented in more than 30 countries and on more than 500 treatment plants. In 2024, in Oman, in Muscat, at wastewater treatment plant Boshar, our technology was implemented first time. In the sewer network and biological reactor, we applied our product. And the results we achieved: sludge for disposal reduction for more than 85%, absolute dry solids. Energy consumption reduction by 35% at the aeration stage, because our technology needs less oxygen. It works with dissolved oxygen levels between 0.8 to 1.2, or even less. Effluent quality improved by improving sludge settling properties. MLSS remains stable, so concentration in the aeration remains stable at 4,000 milligrams per liter, even though we didn't remove almost any sludge. The carbon footprint of the facility reduced for more than 50%, because conventional sludge management accounts for at least 50 to 70% of the treatment plant footprint. The excess sludge is the major issue in the world, because increasing populations contribute to 80 million tons of excess sludge produced every year, dry solids. So what is the solution? How can we solve this problem? Let's make fertilizer, yes? No. The fertilizer using sludge is not the best idea. Sludge contains heavy metals, pathogens, and contaminating groundwaters, polluting groundwaters. What else can we do? We can recover energy using anaerobic digesters, MEC units, and with our technology, we're helping clients to recover better quality biogas with higher methane content in it. But all of these actions contradict with circular economy, because digested sludge has to be still thickened using chemicals, dewatered using dewatering equipment, trucking, transporting from the facility to the landfill, disposed there and stays there forever, or dried and incinerated. And our solution is prevention. So these are the hydro microorganisms, and 50 grams is enough to reduce 150 kilograms of dry solid waste. 50 grams is enough to reduce of digested sludge, had issues, and effluent quality, and we solved all the issues. So speaking about the odors, when I went there, the odors were so bad that the inlet chamber, I was standing 10 meters away from that place, and the odors were just disgusting. People from the neighborhood were blocking the way for the employees to get on site because they were just protesting. And after a couple of weeks of applying the product into the sewer network, 15 kilometers upstream the treatment plant, the odors were gone. Me and my colleagues over there, we went there and we gave interview from the inlet chamber. We stood there for 30 minutes and no odors, nothing. Before, the odors would get into your skin. It was so bad. Not only for population, but for the employees as well. So what we do here with the sludge? The primary sludge from the primary tanks, just at the top, 360 cubes, it all goes to digesters. It's a mesophilic process. The digested sludge with a better quality biogas, with a higher content methane, because our bacteria hydrolyze the primary sludge in the primary tanks, and organic acids, the ready food for methanogens. So digested sludge, 360 cubes, 250 goes back to the inlet, and 110 cubes to dewatering. All secondary sludge from the clarifiers at the bottom goes back to the inlet, 2,000 cubes a day. As for the effluent quality, so they had issues with ammonia oxidation. The effluent ammonia was around 10, right now is around 3 milligrams per liter. The MLSS remained constant, around 6,000 milligrams per liter. The SVI improved from 200 to 100. So less washouts, no odors, and no sludge. Another project, we work in oil industry, treating oil-contaminated wastewater. This is our client in Norway, a company called SAR. They're treating brine, high salinity, high conductivity, COD very high, and all contaminated wastewater as well. So when I visited the facility, we can see on the right left corner, that's how the biological reactor looked like. Full of filamentous bacteria, sludge bulking, no settling. Since we applied the product, these issues were gone. We can see water now in the middle picture, so good settling properties. The H2S during the summer sensors were beeping at 100 ppm. They stopped beeping. The biological sludge was such a poor quality that landfill didn't want to accept it, so they had to transport the sludge to Sweden to incinerate it. Huge costs. So no more biological sludge. Increased treatment plant capacity, so we increased the capacity twofold, so they generate twofold more revenues. Turbidity reduced 3 times. SVI improved drastically. We have all the presentations, of course, to share more detailed ones. And more revenues for the company and no orders as well, no H2S. So today we want to share with you that together we can revolutionize wastewater treatment process and sludge management process by simply adding natural bacteria. First, maturating it, so it's a very simple process. We take, in this case, 50 grams or 20 kilos, mix with potable water, leave it for 12 to 16 hours, they double every 20 minutes, and we apply them into the sewer network or biological reactor. That's it. And the results we achieve: sludge reduction up to 100%. Fat, solids, and grease, elimination from the sewer network and pumping stations. Odors elimination. Energy reduction and aeration stage. We prefer intermittent aeration, so we promote on and off cycles, like 3 hours on, 3 hours off ideally, or even longer off cycle. Better quality methane, biogas, resistance to the shocks, and a lot more, to be honest, just too much to mention. Our product is natural bacteria. Doesn't contain any animal byproducts, not genetically modified. It's natural bacteria, facultative bacteria, grown on bran. They produce their own enzymes. That's why we need so little of the product. So they produce their own enzymes. And they take contaminants as the food and convert to biogases. Simple as that. So how quickly we can expect the results? The results we can achieve, odors will be gone in 2-3 weeks. In 4 to 6 weeks, we can achieve 50 to 70% sludge reduction, absolute dry solids, primary sludge, digested sludge, excess sludge, doesn't matter. In 2-3 months, it will be clear that it is possible to operate wastewater treatment plant without significant sludge removal. Our results are validated by many clients and scientific community. In 2021, 2024, Stuttgart University did 2 studies and achieved and confirmed 82% sludge reduction, absolute dry solids, primary sludge, secondary sludge, any sludge. In addition, our clients can save on wastewater treatment up to 30%, and no additional equipment or adaptation of the facilities required. Registered with NAMA, we are here to help you to get rid of the sludge. Please reach out to us, please contact us. We're here to help you. Thank you.
Thank you, Mr. Romanas, for that interesting presentation. Our final speaker in this session is Esil Giogokiai, tendering team leader at PWT Water. Esil is a highly experienced environmental process engineer with 19 years of expertise in water and wastewater industry. She specializes in process optimization, proposal management, and executing large-scale municipal and industrial treatment projects. The topic of Esil's presentation is advanced water reuse, integrating AI and fourth-stage treatment for sustainable wastewater management. Please welcome Esil.
Hello, I'm Işıl. I'm an environmental engineer, and I'm working in PWT since 18 years. So my company is located, the headquarters are located in Germany, but since 2004, the company belongs to the Amiantit Group in Kingdom of Saudi Arabia. And Amiantit Group is a Saudi leader in pipe and storage and water solutions. So let's pass this advertisements. And our topic was about the fourth stage treatment, which is further treatment after the conventional treatment of the wastewater, and how we try to develop AI systems. I think it's the popular topic today and even yesterday. Many presenters mentioned about AI, so I will also be contributing a little bit to that. So I think in the morning I saw a very similar graph from another presenter as well. We all know the fact that the world is expected to live with extremely high water stress in the near future. Because we need water not only for drinking but also to use for agriculture and for industry. We need clean water, fresh water. But as the freshwater demand increases, we also have to seek for ways how to decrease the stress on freshwater demand. One of the ways is to reuse the wastewater, because wastewater has a great potential to be reclaimed rather than being disposed of. So conventionally, we do municipal sewage plants where we make physical treatment and then biological treatment where we try to reduce the organics, carbonaceous material, nitrogen, and if necessary we do chemical treatment to remove dissolved phosphorus compounds or non-biodegradable heavy metals, some persistent other materials as well. But still this wastewater, after this first stage, let's say, still this wastewater is effluent. It is not something valuable that can be reused. That's why the trend and the need goes to fourth stage treatment. So in fourth stage treatment, the only aim is to find a way to increase the quality of the effluent to a stage where it can be reused. So there are several methods. I think some of the academicians and colleagues in the same sector are very familiar with them. Powdered activated carbon systems combined with filtration, granular activated carbon, ozonation, phantom process, which is an advanced oxidation technique, a carboflux process, which is a, I don't want to be boring, but it's a kind of a powdered activated carbon system as well, a patented process, and PFAS removal. Maybe many of you know what PFAS means. They are called forever chemicals. the hard ones that we cannot remove from wastewater easily, but they make this endocrine disruptors and this cancerous materials, etc. So if we can manage the 4-stage treatment, then our wastewater has a value now. It is not an effluent anymore. With some further additional treatment steps, we can use this wastewater, treated wastewater, for groundwater enrichment, for cooling in industries or as process water in industries, and also to feed the crops in agriculture. Okay, potable is too much for the moment, but it is even possible, let's say. So here you see some main criteria how we define and select technologies. Actually, I think many people are, also the administrations are very aware of these. But for me, the most important part is the operational costs, the energy, chemical, and labor costs. So when we are defining the solution, I think also some presenters also mentioned about it. So we have to make sure that the 4th-stage treatment finds its target. So the responsible administrations, the responsible policymakers should make sure that the treated water, the reclaimed water, will be used for the correct purpose, correct need of the society. So it doesn't make sense to make a big investment from the very beginning for an area where there's no industry, no agriculture, but just to say that, hey, I have very high quality water. But if the responsible companies, if the responsible technology providers cooperate with the administrations and the policymakers, then fit-to-purpose solutions can be found, implemented, and wastewater is reused as a valuable product. So here we see a comparison of the systems and some result of the studies that we have done. In my company in Germany, we have some young engineers, and the company is investing on their academical studies, especially in Darmstadt University. So they are working on the results of some 4th-stage treatment plants, because my company is also operating several plants in Germany, and we have a huge database from our former plants globally in Europe and in Asia. We made many plants in the past. We have a lot of data. Some of them were later on extended for 4th-stage treatment. So we have a huge database. So the colleagues in Germany, along with Darmstadt University, they are making studies. So one of the first studies, here you see the result. The red line, it is not written here, but it shows ozone. The dotted line shows powdered activated carbon. So they are making some comparisons and evaluations. These are only the simplified results, and they are using artificial intelligence techniques and digital tools to come to the result in a quicker way. Here you see that for initial investment, for 4th-stage treatment, powdered activated carbon PAC system is more costly. But when we come to the operation costs, it shows that ozone, using ozonation systems, are much higher, give much higher energy costs, because you need a lot of electricity to generate ozone. But if you have some renewable electrical sources, or if the electrical prices are not that much important, then it can be a good option, because as you see in the third graph, the overall operation cost also is advantageous for ozonation rather than powdered activated carbon. Because we also have to think, like the previous presenter with me, we also have to think about the sludge. because we treat the wastewater and the remaining pollutants, if they remove the water cycle and pass to the solid phase, to the sludge cycle, then also it's another environmental problem. This is also a recent summary of the, I just realized the screen here. This is also a recent summary of our colleagues in Germany about the micropollutants that they were working on. They are working in a very specific way, and it is not maybe for today, but for tomorrow, to specify the micropollutants, to find the best way with today's technology, the best treatment way, to find a way to optimize the past data and with today's data that we ourselves obtain, and the data we obtain from the literature and the universities. This is where we use artificial intelligence because it is too much work. So, to simplify the things, AI models, at the moment we use them to accelerate solution selection. At the same time, we try to reduce the engineering costs, which is an important point, and also we try to reduce the laboratory costs, which is time-consuming and also costly. By the way, before I came to Oman, I made a search for the artificial intelligence in wastewater management, and I found out that Oman is giving a very big importance to this issue, and I wrote it to my hand, sorry, in the University Sharqiya. Did I say it correctly? Okay, in that university, a group of academicians and professors worked for this issue. They have a very highly cited article about this artificial intelligence in wastewater management. They made a research and they made a good bibliographic search as well. What has been done so far, what are the promising ways and methods. It really helped me to understand the interest better. So I just wanted to say that it was really helpful, and Oman is interested in this. So coming back, so in industrialized nations, so fourth stage treatment is being developed. A lot of data is being collected. But if the data is kept on papers, if data is not shared, if the data is not shared with the universities or the researchers or the developers, then the AI system will not be fed. So we have to feed, we have to collaborate to feed the system, to feed the AI systems, so that we can find good models to predict pollutants, to predict other removal methods, to ease the things, to gain time. We can use these AI models. I don't want to go repeat because this was talked a lot in the previous sessions as well. So the result, we expect that we gain time from the engineering, from laboratory costs, and we make savings for the future wastewater treatment plants, which use artificial intelligence methods, and also it is possible to expand the existing wastewater treatment plants for the fourth stage treatment and improve the water reclamation and reuse opportunities. So thank you for listening to me.
Thank you very much, Asil, for this nice presentation. Now we'll start the Q&A session for 10 minutes. I will ask our speakers to join me in the stage, please. Yeah, please. Okay, any question? Yes, please.
Hello, I'm Pawan. I'm representing Nafal and Circle H2O. My question is with Nitin. You have explained about hydrocyclone used from the sludge being taken out from the or MLSS being taken out from the membrane tank, and the diluted part goes to the sludge dewatering and concentrated part goes to the recycling purpose. So I have two questions here. One is that you said this will be overall, energy saving, more pertain to have transmembrane pressure related to, but this hydrocyclone will also consume, because 2 to 4 bar you said the operating, so it will consume some additional energy. So how it does impact on the overall with addition of this section? This number one. Number two part of it, when it is diluted portion is going, so what is the sludge, what is the solid concentration in the diluted part? Because it has to be again dewatered. So if it is already further diluted, so what is the concentration you target on the concentration side and the dilution side, diluted for the hydrocyclone? Thank you.
Yeah, a good question. The first one, like the pumping, like to the hydrocyclone, the volume is not that large that what's MBR is pulling out. Like for the any 10 MLD plant, even the sludge wasting will be like a hardly 0.2%. So the pumping to the hydrocyclone is very minimum compared to the what's it's pumping out by the membrane system. That's one. And the second, it's the hydrocyclone separates underflow and the overflow. But still, we don't see much of the difference in the concentration. On the second slide, I was presenting the mass concentration with the hydraulic distribution on the both sides. It's not that mass distribution also in the same range. So we don't see that lean. The overflow also is having if I am pumping something 10,000 MLSS, so that's also in the range of 8 to that range. Just few hours of the operation of the cyclone increases compared to the earlier sludge wasting. That's what we see. Thank you.
Okay, thank you. Any other questions? Yes, please.
My question to Mr. Romanas. Actually, I joined later for the presentation which you are showing regarding optimization of sludge production. So the material which you showed here, we need to know where it will be applied and how we can know the amount of this material to be applied.
Hello. Thank you very much for the question. So how much to apply? It's very simple. We estimate quantity based on average daily flow and COD. So for example, a city of 100,000 people would produce approximately 20,000 cubic meters of wastewater at, let's say, COD 500 milligrams per liter. We would need maximum 1.5 kilograms of the product to reduce at the yield of 0.4, it doesn't matter, 4 tons, 3 tons, or 5 tons dry solids of sludge, depending on the system itself. It's very easy to use, so you just mix it with potable water and apply it to the sewer network if you want to get rid of the odors in the system, in the sewer network, and pumping stations and the inlet of the plant, or it can be applied into the biological reactor direct. Simple as that. Every day. Unfortunately, it has to be done because to outcompete indigenous bacteria is not easy. So you have to apply it every day.
Did you apply it here somewhere in GCC countries?
Yes, we did a trial in 2024 at wastewater treatment plant Beauchar in Muscat. Achieved great results, confirmed results by Oman Water Services, registered the product, and we are here ready to help As I said before, we work in more than 30 countries on 3 continents, more than 1,000 projects, as big as 1.5 to 2 million people, as small as 500 cubes a day. So we can work with any treatment plan, MBR, MBR, SBR, classical, carousel type, any treatment facility, achieve the same results. Thank you.
Thank you very much. Yes, please.
Assalamu alaikum.
Alaikum assalam.
Dr. Ibrahim Hindi, Water Engineering Consultation. The question for Dr. Sharif is about the energy consumption in IFAS system. You said that the IFAS system is more economic than activated sludge or any other conventional system. So you have a study or anything like this to show that we can save energy for cubic meter of wastewater?
Yes, we have some references about that, but the point here that we can use fine bubbles in aeration system by EFAS. What we don't can use it in activated sludge system, because in activated sludge system we need more power for mixing. And in EFAS case, you can also increase the treatment efficiency to 50% more than activated sludge system. So in this term, maybe you need the same energy, but for double capacity. So this means, in this regards, you can say that we save energy because of the fine bubbles and because of the increasing of the capacity and also the treatment efficiency in the same tank volume.
Okay, another question, the MPPR and IFAS. Do you recommend MPPR as a separate without return sludge more than IFAS, or IFAS is better?
The problem, Julia, is here, and maybe they can attack me like last time. We don't prefer to put the moving bed in aeration tank because of energy consumption. We can IFAS is fixed bed or moving bed in aeration tank.
Yes.
So if you use the MBPR as moving bed in aeration tank, you need more than 30% energy for the same quality. So for this reason, plus there's many operational issue. I was operator in some wastewater treatment plant related to this, and we have a lot of studies. We are manufacturers for MBBR last time, but we stopped doing it because of this energy consumption.
Thank you.
Okay, thank you.
We still have 2 minutes. Yes, please.
Assalamu alaikum. This is Rad from Oman Water. Just my questions to Asil, I think. Thank you for your presentation. Yes, it was very beneficial presentation. So just I'm wondering, in the GCC area, nobody have initiatives to implement the 4-stage treatment. I don't know, have any country from the GCC has been approached PWT to implement the 4-stage? As we know, maybe the law does not support the country to implement the 4-stage. Exactly. It will be portable water, as I believe, correct?
Last verse, you said potable?
Yeah, 4-stage. It will be allowed for drinking.
No. Actually, it is for reuse, not for drinking. So the drinking can be the ultimate step. So we are not like Bill Gates at the moment, let's say. He's making documentaries and saying that, okay, from wastewater we can drink. But actually, the 4-stage treatment has started. In Saudi Arabia, some new tenders, some new specifications are coming for both solids and the wastewater, with Class A biosolids plus for water for reclaimed water. So it has started. But here the problem is also in Saudi Arabia, it is the problem. A lot of plants are built. Even the conventional plants it is difficult to find correct operators and continue the activity of the plants in an efficient way. So if you invest for first stage treatment, then it is an additional part, let's say, to be taken care of. It is very valuable. It will have a lot of positive impacts. It can be used in agriculture and in your industries. It's an industrial area. But at the same time, you need operators to understand and to run the plants. So if I think it's becoming more popular and more important to build plants with fourth stage.
But what happened in Singapore, I think, as I believe, in Singapore they are allowed for drinking fourth stage.
Yes,
correct?
Yes, that's correct.
So just only one country over the world they are using? I'm not sure about.
Namibia?
Also?
Okay, maybe it's too much water scarcity, so they have no other solution. In Europe, still not. I am originally from Istanbul. In Turkey, it is still not. In Saudi Arabia, you have enough energy to take the water from the sea, desalinate, and make it potable water. As long as there's the petrol and you are rich enough to convert the seawater to potable water, there's no problem. But in the middle of Africa, or maybe in the future in Asia, in Europe, maybe we will need to drink the treated wastewater.
Thank you.
That is possible. It's technical.
Yeah, you can.
Please, sorry. Can I just would like to add one idea about, if you allow me. Fourth stage is just to remove micro pollutions, because normal wastewater treatment plants are not prepared for this. And in Europe, they started to reuse the wastewater, and in Brussels last year, it was I was one member of the paper reuse, and they start to use ozone or sense, yeah.
Because when I heard that first stage, that's mean allowed to drink, but now you correct me. Thank you so much.
But they do it. So basically, I think Singapore, for example, is treating the toilet-based water and turning it to drinking water. It has been done, I think, more than 10 years ago. So it's not really that new, but it is not publicly accepted. So due to the religion matter, for example, they had difficulties for about 5 years to convince people that this is basically the bottle of the water which has been purified and turned into the drinking water, because public did not want to accept. But they had problem because, for example, Malaysia changed the price level. They could not buy the drinking water from the Malaysia cheap, and the desalination plant in Singapore was not sufficient. So they had to have 4 strategies, and one of them was basically to turn the wastewater into the drinking water to be on the safe side. I think in Oman, you have wells as a backup plan. If something goes wrong with your desalination, you can temporarily supply drinking water. But I think fourth step gives you peace of mind that, for example, if you are putting RO or other, for example, treatment steps, then you have really a good quality of the water. And even, for example, in some cities in Germany, like Berlin, the water cycle is closed. So basically, if you take a sample, you can see that there are even micropollutants in different surface water, and they end up in the drinking water because there are a lot of old people taking medicine. These pharmaceuticals are basically not treated in the wastewater, given to the surface water, and the cycle is not really that good. So basically, I think in maybe a few years from now, 10 years, could be that basically people accept that the treated wastewater can be further polished and utilized as a drinking water, and it can be as clean as normal water, so that you basically get it from desalination plant. But I think the main bottleneck is how it is publicly accepted by the people.
Okay, thank you. We are running out of time, but please allow me to ask the last question. In order to achieve the circular economy in wastewater treatment, what is the research direction and trend in producing biohydrogen from the sludge?
You mean energy utilization from
Yeah, waste to
sludge?
energy. Waste to energy, yeah.
I can answer this. So
Yes.
we're working with UK company. They have MEC units. So basically, we help them to hydrolyze the waste, the primary waste, to recover more energy from the biomass. So it can be done. It's done right now on a small scale, I believe. But the world is moving in that direction, and we can see innovation in this field.
Can I add? We all in our presentations talked just about wastewater treatment. There is another line, it's sludge treatment. And from sludge, we can introduce energy like gas, and from gas into electricity, and this can be used also for the wastewater treatment. In Germany, the wastewater treatment plants, they produce energy from gas. They have right to buy this energy to the city with more price, and they use also the energy as gas for or electricity for the operation of the same wastewater. This makes cost recovery indeed for this operation, and this minimizes the cost of OPEX and CAPEX.
Can I make a quick point on that?
Yes.
So we tried, at our university, we tried to produce gas from food waste, not, right? And we realized that the price of that gas is way too high to worth economically. So if you produce gas and sell it to the gas market, your business case is not successful. So we realized that an alternative is indeed to produce gas, store it, and have a generator, and burn the gas to provide electricity services to the balancing market in the electricity market. That way you can have a positive business case. And there's a company called POC, and that's been working on it, and if you want, I can...
Okay, thank you very much. At the end of the session, I would like to thank our speakers for their valuable insights, and for your audience, for your contribution and attention. And I hope this session will spark new ideas and collaboration. Thank you very much. Okay. Yeah, we all invite to a group photo, please.
Thank you, Dr. Saud, for the excellent moderation. Now we invite you all to have the group photo. Then we will invite Dr. Saud to give our speaker appreciation certificates. Starting from Dr. Ihsan Muhammad. Dr. Naama Sharif. Nitin Patel. Dr. Shahab. Mr. Romanas. Ishil. Dr. Romanas first. Romanas, yes. Then Ishil. Sorry, yes, because it's taking time to take photos, that's why. Thank you all for attending. We will have a 1 hour break lunch, then we will continue our session at 4:30.
شباب تعالوا تقدموا في السطر الأمامي.
بسم الله الرحمن الرحيم، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. من لا يشكر الناس لا يشكر الله، وطبعا نحن هنا مجتمعين على أساس أن نوجه لكم الشكر. عملكم هو اللي أسس لنجاح هذا الأسبوع، الحمد لله رب العالمين. يعني بعد اللي صار السنة الماضية أنا ما كنت موجود طبعا، البرنامج كان ناجح، لكن هذه السنة ولله الحمد بجهود الجميع، وأنتم الجنود المجهولين اللي فعلا يعني اشتغلتوا خلف الكواليس. في بعض الأشخاص ظهروا أكثر، أنا اشتغلت يمكن أقل واحد فيكم، ويمكن إعلاميا يظهرون نحن، لكن هو في الحقيقة عملكم أنتم أكثر من أي شخص آخر. لذلك نحن نقول لكم شكرا جزيلا، ما قصرتوا وجزاكم الله ألف خير. الجميع فعلا بذل مجهود كبير، اللي اشتغلوا من قبل ما بس في هذه الأيام من بداية، واللي تعبوا نفسهم وجهزوا وساهموا، كل مجهود أدى إلى هذا النجاح. هذه السنة حقيقة الأسبوع هذا شهد نجاح نحن نعتبره إنجاز كبير. هذا الإنجاز يعني يحسب لجميع القائمين عليه، وأنتوا الكور تيم اللي يعني فعلا بذلتوا كثير من الوقت والجهد، ولذلك نقول لكم شكرا وجزاكم الله خير، وإن شاء الله تستمروا معنا ونستمر معاكم السنوات القادمة بإذن الله. أحسنتوا وما قصرتوا. فهي بادرة ممتازة، يعني أنه نقدم لكم شيء ولو بسيط، وعاد سمحوا لنا على القصور يعني. هذه الشهادات. فكرة الفريق طبعا ما فكرتي أنا يعني، وجزاهم الله خير. فنبدأ إن شاء الله نوزع هذه الشهادات.
سعيد حميد سالم العاصمي. عبير هلال عامر الحقري. سعادة يوسف علي النعماني. خليل سليمان سالم العدوي. محمد حارب محمد، نعتذر القبيلة مكتوبة. سالم هلال العبري. مرشد محمد الشيذاني. فهمي الرواحي. إسحاق المصلحي. مريم الفارسي. الدكتور موسى الحنشي. سامي سليمان السليمي. سلام السعيدي. طارق حبيب الرحبي. بلقيس حمد العلوي. سلمى السيابي. حمير العبري. عبير شيدي. إبراهيم بلوشي. ياسر المسكري. إيمان الخروصي. مياد الصباحي. سالم السهلي ولا الشعيلي؟ الشعيلي أعتقد. بلقيس سريري. حسن الوهيبي. حمد الرواحي. هاجر البوسعيدي.
من يصورها؟ من يصورش؟ اوكي. تبادل مصالح.
تو هي المشكلة. عبد الله البلوشي. بيصور على هو.
عبد الله من يصور؟
هذا تحدى. سعود المحرزي. سعيد السبتي. سعد المعولي. سعيد.
لا اسعد وعلي بلوش.
سعيد البوسعيدي.
ميادة ما موجود. ما حد يسلم عن ميادة. من باقي؟ سالم ما موجود.
خلاص.
هذا كلهم خطفين عليه.
خلاص.
ميادة مرتين.
خلاص اعتقد.
باقي سوي شهادة.
حسام يا اخي في اشخاص ما اشوفهم موجودين.
في شهادة.
طب في اشخاص ما موجودين ما حد كرر.
break. In this session, we'll discuss innovation and reuse and resource recovery. It will be chaired by Dr. Farah Al-Barwani, Research and Development Senior Manager, Oman Environmental Services Holding Company, BA. Please.
Thank you for that introduction, and thank you for the speakers. This session will really focus on new innovations and cutting-edge technologies, and I'm really looking forward to the session. Without further delay, let's dive into the future of innovation in this field with our first presentation from Siva Kumar Kota. Siva Kumar is the head of technology at Gradient International Holding with a master's degree in chemical engineering. He's a highly accomplished professional with 7 patents, really highlighting his passion and commitment to innovation and excellence in technology. Without further ado, please.
Thank you, Dr. Farah. Good afternoon. So one of my colleagues, Mr. Shankar Natarajan, he could not able to join for this meeting. On behalf of him, I'm presenting this one. Thanks for your time. Sorry for this. So thank you for the opportunity. So today what I would like to talk about is one of the project where we did it in Singapore, especially for the water recovery and recycle. And it is a wafer fabrication semiconductor industry. And I'm going to present the one case study, especially, why we are chosen this case study is there are lots of potential for the reuse and recycle in Oman also, most of the industrial wastewater. So if you look at the Singapore perspective, so most of the advanced technologies they would like to implement. Main reason is the water scarcity. They are completely depending on the Malaysia and the water desalination. That's the reason they're trying to utilize as much as possible decentralized system. That's where we got an opportunity to work with them on one of the system called local scrubber reclaim. Earlier, before we are starting with this technology, they used to have other competing technologies which were giving them around 75% recovery. So we started with this project and we had a target to achieve more than 92% recovery. And that's where we started this overall project. If you look at the wastewater composition, which is very important and which has been completely, it can be scalable and you can see the same impurities across the different wastewater. One of the important impurities what we have faced, very high variation in the fluoride, silica, and of course the COD and TSS. So these all compounds will very well present in most of the industrial wastewater. Other than the fluoride, definitely silica is a big concern, TSS and COD. So the main purpose and what we want to do is the recovered water should be reusable or equivalent to the new water quality. The objective should have, to minimize as much as possible. They are trying to, buying the new water from the, the municipality. So what we proposed was we did a pilot study in our lab, and it's basically semi-batch mode operation. And our main semi-batch design can achieve the higher recovery. And the semi-batch mode comes in a combination with our artificial intelligence. The main important point when you look at the water chemistry, we do have two main problems, right? One is the fouling and scaling, right? The scaling, definitely we can monitor the calcium or hardness and the silica and the fluoride. The main novelty what we are trying to bring in here is when you monitor these online parameters, you need to find the scaling potential. So we do have an algorithm to identify the saturation index. Main important parameter after identifying the saturation index, you need to find the induction time. The induction time is nothing but the time required to a particular salt to precipitate onto the membrane. So if you take an example of sodium chloride, if you mix with the water until certain limit, it will be saturated. After that period, it will be supersaturated. Similarly, like a calcium carbonate, calcium sulfate. So these all will have a different induction times. Calcium carbonate can be immediately precipitated, but whereas calcium fluoride and silica, it will take minimum 30 to 40 minutes time to precipitate onto the membrane. So we utilize all these induction time phenomena and try to monitor the scaling and the fouling potential. And when you compare with multi-stage RO, we will be using a single stage, and it is a very flexible and adjustable for the recovery rate, and we can reduce the fouling and the scaling potentials also. So how our system works, right? The key features are the semi-batch mode operation. If we do have two main the cycles, right? One is the operation cycle, which if you look at the picture, right? So here, I could not have, let me see if it is working for the, no. Okay. So, okay. Yeah, okay, maybe. Okay, sorry. I think maybe if you look at the process flow diagram, right, how it works is you have a high pressure pump and RO system. Initially during the production cycle, with the cross flow pump, continuously reject will be sending back to the upstream of the the RO system. So using the artificial intelligence, it will have a 3-4 parameters. Conventional, what you do is the cycle time. You will give a fixed time, 30 minutes, continuously recycle, and there will be a other variation will be like conductivity or the pressure delta P. And another important point, what we induce is induction time. As I mentioned, induction time is directly proportional to the scaling, and of course it is directly it will give you more information, or it will be a very important parameter in terms of running for a higher recovery. So based on any of these 4 parameters, whether conductivity or pressure or induction time, whichever is the triggering the first, then it will be the bleed valve or reject valve will open. Then during that time, permeate still will be produced. Whatever permeate is produced will be recycled back to the feed stream. The main reason why we are using as a permeate flush is the permeate will have a good quality water. So this will give us you call it as hungry water, right? If you have used a good quality water, it has a potential to dissolve more minerals in it. So we do the permeate flush for within less than 90 seconds or less than 2 minutes. That will allow the, it's indirectly call it as a resetting the membrane system. So that's where we can restart the new cycle. So for this particular case study, what I mentioned, local scrubber water, as a calcium fluoride and silica, these two are the major impurities apart from COD. What we have as a process scheme of pretreatment. In the pretreatment, it constitutes auto backwash filter and ultrafiltration and activated carbon filter also. Particularly, this water has a very high H2O2. As I mentioned, as a composition perspective, apart from chlorides and silica and TSNs and COD, it's a semicon industry wastewater. It comes with a very high H2O2, hydrogen peroxide, and it has a very high amount of IPO also. So for those all parameters, especially H2O2, to nullify the oxidizing effect, we use the activated carbon filters also. followed by our RO Infinity technology. And particularly this plant has, 4 trains, out of 4 trains, each train has a 90 meter cube per hour capacity. And each vessel have, 6 elements as a total system. If we look at this plant, right, we installed in 2022. As of today, it has been running constantly. Initial period during the performance, demonstration period, we collected several of the data. So what you see, the one of the data, flow rate was varying from day 1 to day 4, 90 to 100, and average is 100 meter cube per hour. So we got a plant recovery around 88%. Only RO recovery alone, 92% we got it. And the treated water quality which we need to meet is less than 300 microsiemens per centimeter. Other than that, as I mentioned, they do have a limits for the fluoride. Fluoride has to be less than 10, and also for the ammonia and other subsequent parameters. So if you look at the results, right, this is a real plant data we took during the demonstration stage. So the 3 key parameters has been listed here. If you see the cyclic or the the start of the RO's operation, initially slowly feed pressure will increase as we are trying to send the recycle the reject continuously. At the same time, permeate conductivity also slowly increases. Once it reaches to the triggering point, as I mentioned here, apart from the conventional, TDS based or the conductivity or the delta P, we use the induction time also, one of the key parameter. Out of these 4 parameters, whichever is the first triggering point, it will start the flushing sequence. So once the flushing sequence is indirectly, it is resetting the overall system. Once the flushing is completed, again the production will be starting. So in that way, overall period, the permeate also an average, if you look at in a permeate tank, it is always we could able to get less than 140 microsiemens per centimeter. The reject conductivity also slowly, it is in this picture, if you look at the reject versus a permeate conductivity. As the reject conductivity increases, it is directly proportional to the recovery also. As the recovery increases, reject and subsequently permeate conductivity also slowly increasing. Once it comes to the end of the cycle, the transition of the flushing will start. Once the flushing is started, it will be starting the new batch of operation. So in this way, we are trying to minimize the scaling, and this semicon industry having the very high flow rates. In that way, overall last 4 years, whatever 3 years completed, we didn't change the membranes, and also the CIP cycles we hardly had every 3 months or 6 months once only. If you look at last 3 years of operation, we had 10 to 12 CIP operations. And still the plant is running more than 92% with overall recovery. The cyclic trends, what it shows is the ROI differential pressure. As I mentioned, it is always maintained at 0.71. So this gives one of the indication for the health of the membrane also. So in conclusion, with our ROI semi-batch mode operation can be successfully demonstrated at this plant, especially semicon wafer fabrication unit for the local scrubber system. So particularly in Oman region, wherever you have a wastewater, especially treated sewage water in Abu Dhabi and other applications, where we see the high fouling or house scaling perspective, we could constantly utilize this technology to achieve greater than 90% recovery. And based on this technology, we have been subsequently implemented in other industries like textile industry and the mining industry. So mining industry, our competitor could able to achieve 30% recovery because very low TDS, low pH. pH was around 3 pH, and the very high TDS also, which is scale causing, very high potential was there. still with our ROI technology could able to achieve more than 65%. And particularly this ROI in brackish water range, we confidently can be go above 90% recovery. But if you are going for very high TDS above 100,000 also, we can able to achieve more than 50 to 75% with a single stage operation, So it is a reliable one, and it has been operational for the several years, and definitely it will be useful for the, any wastewater application. Thank you, and looking forward for any questions or anything you would like to know. Thank you very much.
Thank you for that presentation. What we might do is keep the questions to the end. We'll bring the panelists all to the front at that point. I think after that insightful presentation with starting with some good innovation, let's move on to a local context where we talk to Dr. Mahad Isa Shammas, head of the Civil and Environmental Engineering Department in the College of Engineering in Dhofar University. If you can help me welcome him to the stage, he's going to be presenting about water resource management of Salalah Plain Aquifer using a sustainable approach.
السلام عليكم ورحمة الله وبركاته. مساكم الله بالخير. إن شاء الله بعد الغداء تكون لازلت أكتف إن شاء الله. وأنا بحاول أتكلم بحيث إنه إن شاء الله تكون أكتف. Okay. طبعا أنتم as you know that we are talking about municipal water and wastewater, but I'm also related. My course is a little bit about groundwater. But it's related to also municipal wastewater I mean, how we use municipal wastewater to use it or reuse it, so it will be more efficient or for the future. So as you know about water resource management, I mean, now we are facing problems of water resource management or water resources. We have less water, groundwater, so we can also reuse the treated wastewater. So we can't use the treated wastewater to, balance the groundwater. So this is, the idea of my paper or my presentation. I will start. Outline, everyone knows that will follow this outline. The problem is that, as I told you, we have always offer abstraction for all groundwater everywhere, and especially in the groundwater which is close to the sea. So when you pump a lot from that groundwater and you don't have enough recharge, so you'll have seawater intrusion. You'll have seawater intrusion, and then this is a big problem which is facing most of the groundwater. They face this difficulty. How we balance this, since we don't have, we have discharge more than recharge. This is the problem. Always we discharge more than the recharge. Also because of the climate change, recharge is less. Rainfall is less, and also sometimes there are some precipitation, not only from rainfall, as maybe I will mention. So we have to manage this problem. I used mud flow or modeling to see this sustainable aquifer management, which I proposed. I proposed some scenarios to manage this aquifer by using mud flow or groundwater mud flow. So material and method, as I told you, I have 3D groundwater simulation, and also I use MT3DMS for solute transport, because you have to see also the flow of the water, and also you have to see the solute or this, the TDS or the salinity, how it is also, how we control it. Also, we see also another code, which is the PM bath, also to see the infection transport of the water, I mean, in the groundwater. So this is, I mean, I used this, this idea since I did my PhD in Sweden in 2007, that time. So I'm following up, I'm doing a follow-up to every 5 years. I see the aquifer, how it, the status of the aquifer. Is it okay? Is it deteriorating or not? So you can see here my papers, some of them since 2008. So I mean, I'm following up with that scenario. Okay, here I have some results. In 2011, I told you that a long time back I have similar to these maps. I already generated many of them since 2007. But for example, I see here 2011, and you can see the, I mean, the saline intrusion. You can see the zero level above sea mean level. I mean, zero is just the water, the sea water level. Sea water level is zero, you know, all of you. And it should be, groundwater should be above zero, always. At least 0.1, 0.2, like that. But once it's, I mean, zero, that means you have a saline water intrusion. So in 2011, you can see there, there is a zero. It reaches even 2 kilometers inland. If you go, you can see the, I mean, the area from the zero there is the coastline, the sea. And I mean, the inland is there, the Salalah city. This is Salalah. So you can see, I mean, it reaches, I mean, maybe 2 kilometers. That means we have saline intrusion in that area. I have, you know, for also many maps, but I go to the prediction, which I have. This is the scenario which I created, and this is also a published paper. In 2027, we say, okay, if we do business as usual, I mean, we don't do anything. Just we wait, and we see, that's called business as usual. You know all about this. So what will happen? And now, this, I mean, the map shows that the wedge of saline intrusion was delineated from the shoreline 750 meter in line. That means there are seawater intrusion, and it will reach 750 inland if we have business as usual. But if we have another scenario in 2027, this is a prediction. I mean, I'm predicting. This is a sustainable management. I'm doing prediction. If there is we stop pumping from the groundwater aquifer. We have here in Salalah, you can see there, where Salalah Willfield. Salalah Willfield is just north of Salalah Airport. North of Salalah Airport. We have a Salalah Willfield. It used to, these pump wells used to be used for drinking water, to supply water to Salalah city. But now they are still using it, but not like before. Before Salalah city depend on groundwater in this well field, 100% before. But since 2013, we have a desalination plant. We have 2 desalination plants now in Salalah. So we have water, drinking water from that desalination plant. So we don't, pump from this aquifer for drinking water. We pump less. I mean, Nama Dafar services. They pump now less from this well field for drinking water. So now, if I said, we have to stop pumping from the well field for the groundwater, for water supply. We have to use the desalination plant instead. Khalas, we don't need you to pump any water from the aquifer for drinking water. So this is the scenario it shows now. We allow the aquifer range to level and to turn to its steady state. Now the aquifer will be managed. It will go to its steady state. And this is, this is the management which we want. So now this paper already published and it's sent to NAMA, and they know that, they should stop pumping from this Salala aquifer. For agriculture use, we cannot control the agriculture use. We are pumping more than around 50 million meter cube per year for agriculture. We have more than 1,500 boreholes or wells that they pump for agriculture. You can see the agriculture there, and the green, this is, the farms are there. So this is another challenge which we cannot control. We just control the drinking water or water supply from groundwater, because the government can understand and can implement the recommendation. Okay, we go to now, this is the same what I said to you now, but I go to this another model, which I told you one is for flow, and this is for also saline intrusion, for solute transport, TDS. Water resource, I took this data, water resources used to have data. Water resources they used to have data. They they make a monitoring for water level in the groundwater and also for TDS. So I took this data and I input all this data in my model. So you can see here in 2027, with the scenario B, which is business as usual, we have saline water is there, but when we have business, scenario A, which is we have to stop pumping from well fields, Salala well fields and Saada well field, which is north also of this area. So then salinity level will be returned to steady state. Here we can see that, also, okay, TDS also decreased by 15% if we, in scenario A compared to scenario B. Here also the other model, which is PM bath, mud flow, advection transport. It's also similar to the mud flow. So here also in 2011, you can see here, you can see the zero. Where is the zero? It's 2 kilometers inland. That means we have seawater intrusion. And I want to tell you about you see the green cells that are there. These are the injection wells from treated wastewater. These are the injection wells. I think I have to go back. No? Okay. Here, the green down there is the injection wells. Here in Salala, since 2005, we inject the treated wastewater. You know, the treated wastewater, we inject it in boreholes in a depth for 48 meters in the layer 3. There, you remember, we have agriculture there. But we bump from the first layer which is about 10 meters only, 7 meters, 10 meters. So then, there is no direct connection between the layer 3, which we inject the treated wastewater, and layer 1, which we pump for irrigation. So, the impact for pollution is not there. So we do this injection to half salinity, to stop the saline intrusion. This is one of the management. So all my scenario is also the injection is there. Injection of treated wastewater, and it's about 1.5 kilometer or 2 kilometers from the shoreline. It's not far. It's in the coastal area. So here you can see also the scenario here when you have, we stop pumping from the well field, and you can see look even 0.5, it's above mean sea level, it's close, 1 kilometer maybe from the shoreline, and you can see the bumping, how it pushes back the seawater intrusion. This is now that the wastewater, the injected wastewater, they push the saline intrusion back, and you can see it there in this. And you can see the water level now, how it improves very well with this scenario. Conclusion, from this results, we can see that scenario A is, we have to, I recommend to use the scenario A, because scenario A, we have to, we stop bumping from groundwater for water supply, and then we see that we improve our groundwater. And it will also, for both, for the salinity and for the water level, both they improve with using scenario A. And when we use scenario B, which is business as usual, it's not a solution. We'll have the same saline intrusions there, and you can see here, it will reach sometime 800 or 700 inland when we are just using business as usual. So this is the recommendations, and under constant underflow, option A seems that the best management scenario in terms of increasing groundwater level and also increasing and reducing the TDS. So why also reducing the TDS? Because the treated wastewater, the TDS of treated wastewater is within 1,000 milligram per liter, more or less, 1,000. But saline water in groundwater, it's more than, sometimes it reaches 5,000, 6,000 milligram per liter. So that means when we inject treated wastewater, it has less TDS than the brackish groundwater. So that means we also reduce the TDS. I think here I finish my time. So thank you very much for listening.
Thank you for that insightful presentation. I think when we talk about innovation in wastewater treatment, it's really driven by the challenges that we're facing, right, with water treatment in general, and that was really highlighted quite well in this presentation. Now moving on to our next presentation. Our next speaker is Mr. Marcus Vollmer, a process engineer with over 25 years of experience in wastewater treatment, but also CEO of BioWorks. He spent more than 15 years in global business development and sales, but also has advised multiple theses in wastewater treatment and business administration. And he's driven by the belief that successful companies should not only be measured by profits, but by its positive impact. So please welcome me in, or join me in welcoming Mr. Marcus Vollmer for his presentation.
So thank you for the introduction. I'd like to welcome you, and I'm very happy to be here to give you a short brief about the company BioWorks. And I brought with me a case study how valuable treated wastewater is and how it can be used. So the biggest problem what we are facing is water scarcity. I think everybody knows about that. And our vision is to develop the wastewater treatment plants, not to wastewater treatment plant and throw the water away, that we want to have the wastewater treatment plant as a water production center. BioWorks is a company located in Germany. we are part of the Hassan Alam Group, and we built over 200 wastewater treatment plants in more than 20 countries. And if you sum up all the wastewater, you can say that approximately 15 million people, or wastewater from 15 million people, are treated in wastewater treatment plants built by Bioworks. We are a process provider, so this means we are working with different technologies, with extended aeration, where I will show you a showcase where it's possible to use earth basins in order to reduce the capex. We're building MBR plants with some clever membrane cleaning. ASBR plants, we're also utilizing existing lagoons into full BNR plants. We also do rehabilitation works on wastewater treatment plants, of course, conventional activated sludge. And what I'm talking about today, treated water reuse, is also a big item in our portfolio. We have a quite big range of equipment which we produce by our own. This is mainly equipment for aeration, some equipment for clarifiers, and also equipment for filtration, for example, MBR membranes or disc filters in form of Pyclos filters. If you talk about wastewater treatment reuse, you often talk about MBR. We are quite familiar with MBR plants. We built many MBR plants. This is a good solution because you can achieve very good effluent values. It is a little bit more sophisticated, but at the end of the day, it is a possibility how wastewater can be treated and can be reused. But for today, I would like to show you a showcase with a much more simple way of treatment, which with very easy and compact design. As you can see, in this plant is built more or less in one basin, just separated the treatment steps by separating walls. And we have quite high cost savings on the capex because the basins which you see, they are built in earth basins, and I will go into that a little bit more in deep. So from the process, you see we have a classical process with inlet, coarse screen, fine screen, and sand trap. This is number 1, 2, and 3. And then we build the whole biological system in one basin, and the treatment steps are separated by separating walls. So this means even if we talk about extended aeration process, we can have a very competitive footprint compared to the conventional design. And then number 8 is the effluent filtration. And of course, we will have some sludge to be treated, to be dewatered, which you will see there on number 9. So you see it's a quite compact design, which we normally use for this kind of projects. If we go now for the showcase of 6th of October in Egypt, this is a wastewater treatment plant for 100,000 cubic meter per day, around 600,000 population equivalent. As I already mentioned in my overview, we have a classical pretreatment, try to make it in a compact design with coarse screens, fine screens, and in that case, we have circular sand traps. The biological treatment tank is a little bit more interesting because this treatment tank is built as an earth basin with HDPE liner. And if you go with this construction, then you can save easily a range of 30 to 40% of the capex on the civil works for the basins. The HDPE liner is also very durable. You have minimum 50 years lifetime, and you have a very, very short construction time, which you will see here. So the whole basins were covered, which are in total 70,000 square meter of HDPE in only 8 weeks. So this means you just have to build the basins, and then you cover it with HDPE, and your wastewater treatment plant is almost finished, let's say, of the biological tanks. So this is a big advantage what you have, especially if you have an emergency project, that you can have very short construction times compared to the classical approach. Why can we design with this earth basins with HDPE liners? Because we have a floating aeration system, which you see on the picture on the right down. So the diffusers are not fixed on the ground, as you may know it from the classical solution, where you have tubular diffusers or fixed diffusers fixed on the ground. They are hanging at these floating pipes, which you see here. So this means the floating pipes are swimming more or less on the water surface, and then suspended from there are the diffusers. And if you use such an aeration system, then you are able to build the whole biological tank in an HDPE line basin, as you can see it there with the picture aeration installation. Now I have a video, which I'm not sure if I can start this, unfortunately. Anyhow, this is just a video showing how this aeration works. This means the air goes through the main air pipe into the floating pipes, and from the floating pipes it goes down to the suspended diffusers. The beauty of this system is also that maintenance of the aeration system is easy. It means, since the diffusers are not fixed on the bottom of the tank, you can float up the diffuser, each diffuser separately from all the other diffusers to the water surface. So this means if you need to do some maintenance on your aeration system, you can float up the diffusers to the water surface and can do maintenance. So this means draining of the tank is not necessary. You can keep it in operation and can do maintenance on the diffusers under full operation of the plant. The clarifier is, in that case, it's a rectangular sucking scraper. So you see the number 8, there is the inlet to the clarifier. Number 9 is the outlet of the clarifier. The secondary sludge is settling to the ground and then is sucked through the sucking pipes. This is number 1 to the return sludge channel, which you can see is number 4. And in operation, it looks like this. So this means you have a traveling bridge. The traveling bridge moves always from one side to the other. So you will have a very, well, you're sucking the sludge from all over the bottom of the clarifier, bring it to the return sludge channel, and from the return sludge channel, it flows by gravity back to the biological system in an open channel, because this is easy also for the operators to understand. The plant is designed in that way that we do not have so much intermediate pumping station or pipelines underground. Everything is quite open and easy to understand. These are the results. So this means with the biological treatment plus gravity sand filter, we are reaching the COD of less than 15, BOD less than 5, and TSS less than 3. This water is then disinfected with chlorine, and then it is reused for agriculture purposes. So you see the original landscape. Then the start of the construction of the plant was in 2013. Only 2 years later, the plant could go into operation. So this means there were only 2 years construction time due to the earth basins with the HDPE line construction. And then after the plant was in operation, the effluent water was reused for agriculture purposes, and you see on the picture right down that only after 4 years you have a very nice green belt grown around the wastewater treatment plant. So this is a possibility to go with an extended aeration, with a clever design, with comparatively low capex, to have very valuable good with the treated wastewater and go for irrigation purposes. You already mentioned I'm done with my 15 minutes, so thank you very much for your attention, and of course later on I am open for any further questions. Thank you.
Thank you for that presentation. I think it's why we're here today, to hear about new innovations. And that was definitely one that I think there'll be a lot of questions on. If you can help me welcome our next speaker. Our next speaker is Dr. Mohammed Murad, an expert in environmental and wastewater engineering with over 20 years of experience. He's currently the country manager for Circa in KSA, but also development manager in Kuwait and Bahrain and the Middle East. He leads projects in water, wastewater, and waste management, and has contributed to significant initiatives such as strategy development. His presentation is entitled Sludge Treatment, Disposal, and Resource Recovery, looking at techniques for effective treatment and safe disposal of sludge, along with innovations in recovering valuable resources. Welcome.
Good afternoon, everyone. First, I'm very happy to be a speaker on this topic for the second year in a row. Last year, I did also a presentation about sludge management. And today, we are here to talk about current practices and also to talk about innovation and the opportunities for the region in the coming few years. So my presentation will be in 5 parts. The first one, water waste. So I borrowed this title for the slide from a report of the World Bank about waste management. I will present water waste from 2 points of view. The first one is negative, about sludge considered as waste, but the second one about how we are wasting this resource. Second part of the presentation is about a panorama of treatment and resource recovery processes. In the third part, I will present the innovation in resource recovery and describe the opportunities for the region, Middle East region, and in 5, I will give some conclusions. So I'm representing Surica, which is a consultancy arm of the Veolia Group. I think most of you have heard of Veolia. Surica, we are the engineering consultancy company of the group. I think all of you have seen the Veolia presentation, so I will not stay much on this. Also, Veolia and Oman, we are well present in the country in the different businesses of the group. I will spend a little bit more time on the global footprint of Veolia in wastewater management and also sludge management. So Veolia is operating a contract in 35 countries for wastewater and sludge management. We are providing services for more than 100 million people. We are treating or managing over 10 million tons of biosolids, sludge, per year. And we are operating 3,000 200 wastewater treatment plants. 200 of these plants are above 100,000 population equivalent. And we have a very, very good contract renewal rate, which is above 90% overall. So water waste. Just before starting, we continue to talk about the leftovers of the wastewater treatment as sludge. And for the past 30 years, there have been attempts to change this and use biosolids instead of sludge to give more, to look at this biosolids from a more positive point of view. So on this slide, I will talk about sludge, but from the next slide till the end, I will be talking about biosolids. So wastewater sludge. So I think many of you know what is it. It is a substance, not very nice to see, not very nice to smell, and even not very nice to touch for the ones who did the experience. And you have a full list of negative things that we can attribute to sludge, and it goes all over the full value chain of sludge management, from generation in the wastewater treatment plant to transportation and even valorization, because it can be dangerous, it can be toxic, it can be whatever you want. So this is why I put it's a substance that is hated by design. But what if we look at sludge from a more positive point of view? I will talk about valorization of biosolids from two perspectives. The first one is energy, and the second one is nutrient and nutrient recovery. So the first one, please bear me with the numbers, and if you don't want to follow the numbers, just trust me. So I took the Middle East region, okay? So we have around 400 million, a population of 400 million, and we know that every person produces between 15 to 25 kilogram of dry matter in terms of biosolids per year. So if you multiply this, you get 8 million tons dry biosolids per year for the Middle East region. We know that 1 ton of dry biosolids can produce 250 to 400 cubic meter of biogas. And each cubic meter of biogas is 1.5 to 2.5 kilowatt hours. So if we put the numbers together, we get for 1 ton of dry biosolids between 375 and 1,000 kilowatt hour per ton. Of course, not all the sludge can be converted to biogas because not all the sludge can be captured by facilities producing biogas. We consider that a viable biogas project is correspond to a wastewater treatment plant with a size of 100,000 population equivalent and above. In some cases, it's less, but if we consider this, we have 70% of the population in the Middle East living in cities above 100,000 population equivalent. So I took 70% of the total population, and if we consider the average price of electricity in our region for industrial use, it's approximately 5 cents of USD dollar per kilowatt hour. If you compare it to Europe, in Europe it's more than 5 times more, 5 to 6 times. So, how much we produce electricity with these numbers over 15 years, which is a typical, let's say, lifespan of a biogas and electricity production facility. We reach approximately, I didn't put the number here, so I put only the figures in terms of USD, but in terms of watt hours, we are around between 30 and 80 terawatt hour per year. And to give a little bit of more perspective, it's more than enough to power Oman for one full year. Okay? So this amount, if we consider the rate I put here, the 5 cents, will generate revenue of 1.6 to 4.2 billion USD. It's not much considering 15 years and 400 million people. Okay? But this energy produced by a wastewater treatment plant can cover up to 60% of the wastewater treatment plant demand. And this energy is considered green and renewable. So it's a much needed energy to decarbonize this activity of wastewater treatment. Same exercise, but on the nutrient side, I will not go through all the numbers. I will just give you what I get if I consider the sludge as nutrient and apply the current prices for the different category of nutrients. And we obtain like 11.4 billion USD over 15 years of revenue. So not to mention that I didn't include here the benefits of organic carbon that can go back into soil in our arid region, which is very, very poor in carbon, which is necessary for life in the soil. Very quickly, this is a comprehensive, let's say, routes of treatment and valorization of sludge. So we can categorize the final valorization into, let's say, 4 categories. The first one is energy. The second one is for agriculture and environmental use. And the third one is resource recovery, mainly nutrient extraction. And the fourth one is as material for industrial integration. It's a little bit difficult chart to really follow every arrow, but you can see that biogas and biosolids can generate energy, biogas, solid biofuel, liquid biofuel, and electricity. Agriculture is from direct application of biosolids with or without drying, by composting, or by drying and pyrolysis, which will generate biochar at the end, which is used as amendment for improving the quality of soil. And also, the biosolid is used for ground or soil rehabilitation and landscaping. And at the end, from the incineration of sludge, we recover the ashes, and from the ashes we recover nutrients, extract nutrients, and also we can use the ash for industrial applications. So what are the current innovations in terms of valorization of sludge and treatment? So it's not necessarily innovation in terms of, let's say, recent discoveries or recent developed solutions, but it's more in terms of adoption at, let's say, commercial scale or pilot scale and so on. So some of these technologies were developed long time, but started to be adopted recently. So first one I will talk about very quickly. Oops. So smart monitoring systems by leveraging the power of AI and IoT, and it's basically used to improve the quality and the consistency of the sludge, because there are two challenges in valorization of sludge. One is the quality of the sludge. We need it to be to have less contaminants, and the second one to have more or less homogeneous characteristics. Second part is enhanced anaerobic digestion, and these technologies are used to improve the performance of biogas production, and therefore the recovery in terms of energy as heat or in terms of electricity. Advanced thermal processes such as gasification and pyrolysis technologies, and also biocrude, so sustainable aviation fuel. So gasification is very interesting. However, it's still applied at very small scale, except one case, which is to the other extreme in the United States, where the New York and New Jersey. So yeah, okay. New York and New Jersey are using a huge gasification plant to treat or to dispose the sludge. So the sludge is reduced, the volume of the sludge is reduced by 95%, and what is left is ash that can be used in industrial application. Pyrolysis technology is more used in Japan, for example, and just gasification is also used in Australia, but at smaller scale. Biocrude, this is very interesting application, but it's still in development in UK basically, and in the United States, but also in our region we have our share of it, because there are attempts in Qatar to produce SAF, so sustainable aviation fuel, from biosolids. And the last one is really nutrient recovery, basically phosphorus crystallization, and the other ones are to extract nutrients such as nitrogen and also phosphorus as a high-value fertilizer products. This is a topology of what we do in the region in terms of sludge, of biosolid management. So basically, it is landfilling and composting. Okay, composting is very also okay. Let's say specific application. It's only in Oman, which is something I like very much. And these countries and these plants are operated by Veolia, but it gives an overview of what's happening elsewhere. So the opportunities for the next 5 years in the region are basically for producing biogas and energy recovery and composting. And composting or direct application of sludge is basically related to big initiatives in terms of green or climate, with climate aspects like Saudi Green initiative in Saudi Arabia, basically. As conclusion, we live in a region which is avid of new technologies and higher standards, but also we have a big issue is we are slow in taking decisions. But on the other hand, we benefit from very quick adoption once decisions are made. So how the change is expected to be done? First, by regulatory and policy change, and second, by leveraging the potential of climate and green financing. Green initiatives, as I mentioned, it's mainly in Saudi Arabia, but other initiatives are developing elsewhere, and this can be a very big push to change things. And the last one, which is very important for me, and we see signs that started to be done in the region, understanding the risks, so the biosolids quality, and understanding the opportunities, market for byproducts valorization. So this kind of studies needs to be done. It started to be done in Abu Dhabi, it started to be done in Oman, and I think the ball will roll on. Sorry, I took more time, but.
Thank you for that presentation. Now I need to drop the mic, I think. Thank you for that presentation. And I think it showed a number of new technologies that can be adopted, and the ending was I think something that speaks to a lot of our hearts about the need for the policies and the push to actually get these things on ground and implemented. Our next speaker is Oriol Monomi, a research and development technician at GS Inema Environment. He holds a degree in chemical engineering, but also a PhD in water science and technology. He's conducted his doctoral research in collaboration with the company that he now works in, and currently focuses on R&D with the really cutting-edge wastewater treatment technologies. His presentation is entitled Stabled and Controlled Programox Process to Achieve a Suitable effluent quality and bring wastewater treatment plants closer to energy neutrality. If you can help me in welcoming him to the stage.
Hello, thank you for the presentation. I'm going to talk about the Programox process. This is a process that we are developing in INEMA. And just to introduce, wastewater treatment plants, normally they are formed by a first primary settling of the wastewater, followed by activated sludge. Activated sludge is the technology that predominates all over the world, and it has an energy consumption. Also, there is a sludge production that through anaerobic digestion can be used to produce methane and after cogeneration, energy. So we have energy consumption and recovery. The consumption in wastewater treatment plants in Spain is around 0.4 kilowatts per hour per cubic meter of treated wastewater. Around the world, this number is between 0.3 and 0.6. Okay? Which is the consumption of the wastewater treatment plants compared to the country electricity consumption? So, United States, for example, 3% of the country electricity consumption is used to treat the wastewater, and in others up to 5%. So it's an energy-intensive industry. In the wastewater treatment plant, the biggest part of this energy is destined to the aeration of the activated sludge process. There's a part for organic matter oxidation and another part for the oxidation of nitrogen. So a sustainable and efficient approach would be to reduce this aeration for the treatment. Regarding the energy recovery with the anaerobic digestion, if we assume typical numbers, we can get nowadays with the existing technology 50% recovery of the energy consumed. Okay, so we are still energy consumers. So how could we enhance this consumption and recovery? We should redirect the influent organic matter to the anaerobic digestion. We have to maximize this redirection. So within this introduction, we propose a solution which is the Programox process. Is in the mainstream of the wastewater treatment plant. Okay, we propose a process that consumes less aeration and produces more biogas. Okay, this is a mainstream 3 stages process. We have a first stage in which we maximize the COD redirection to the sludge line to produce more biogas. We have a second stage which is based on aerobic granular sludge technology adapted to partial nitritation. And finally, an Anamox reactor in the mainstream to remove the remaining nitrogen in the water. We have registered and patented in Spain this technology, and we have developed it in collaboration with the Lequia Research Group, which is from the University of Girona in Spain. And to do this, we have worked for 4 years now in a pilot plan. This is the pilot plan. We have the 3 stages. It's located in Spain. It's a mainstream pilot plan, so we are piloting only the water line. The influent is real wastewater from the plant in situ. And the volumes are around minimum 1 cubic meter per day. So we are in a quite big pilot scale. So the first stage is based on the high rate activated sludge technology. This technology the diagram is rather simple. It's based on a first activated sludge reactor followed by a settler, but it works at high load. So this means that the hydraulic retention time is 1 hour. We have 2 grams of total suspended solids in the reactor, and the SRT is less than 1 day. So also we work at low oxygen, dissolved oxygen of 0.5. And what we have is COD removal efficiency, a mean COD removal efficiency of 50% with more or less 20% of soluble COD removal. So we have more COD removal than a conventional primary clarifier, which would achieve normally 30–40%. So in this regard, we are redirecting more COD. The second stage, okay, we have the first one, the Pronox high rate. But we have an effluent with still a little bit of COD and all the nitrogen and all the phosphorus. So we have to remove them. In the second stage, the partial nitritation AGS, we want to develop in a reactor working as an SBR, aerobic granular sludge, to enhance the biomass settlability and to be able to reduce the footprint of this reactor. And then we want to do partial nitritation. So in conventional nitrification, we have the ammonium, we oxidize it to nitrite and then into nitrate. So in partial nitritation, we stop at nitrite, NO2, and we save up to 60% of oxygen. To develop the granules, we have worked with a strategy of selective wasting of the biomass. So if the reactor is a column, we let the biomass settle during 30 minutes, and then we do the solid wasting at a certain height of the reactor to select the good settling biomass and waste the rest. So with this strategy, this is some data or some evolution of the solids in the reactor and its SBI. And what we achieve is a biomass with a very good SBI of less than 100 milliliters per gram, and these conventional granules, okay, of 1 millimeter of diameter, more or less. And then we also observe a coexistence between more or less 80% of granules and 20% of flocks, which is not a problem. It's just they coexist in the system and they work well. Regarding the partial nitration, how we did it? The objective was to inhibit the NO2 pass into NO3, okay? So we work with the free nitrous acid strategy inhibition, which inhibits the bacteria that transforms nitrite into nitrate. Okay, free nitrous acid is the conjugate acid of nitrite. Okay, so temperature and pH have a role, of course, and in the end, we know about, for the literature and studies in the lab scale, that we have to have at least 0.03 milligrams nitrogen per liter of free nitrous acid in the reactor to achieve these conditions. So we operated the reactor to have it, and in the end, as we can see in the nitrogen species evolution in the influent and effluent of the reactor, we achieve a stable influent with nitrite and no nitrate. Okay, so we have the reactor adapted to partial nitration. This is published. This is available in a journal, so you can check it out. Finally, however, we have the third stage of the process, which is the Anamox stage. Anamox is implemented in the side stream of wastewater treatment plants all around the world now, but not in the mainstream. No, it has not been yet implemented. It's being studied in the pilot and lab scale. So let's see, in our case, how it works. So we have our effluent now. We have very low remaining COD and ammonium and nitrite. So we propose an Anamox reactor, a continuous stirred tank reactor, okay, with a Bayfeld settler incorporated in the reactor, and we want to achieve less than 8 milligrams of total nitrogen per liter to achieve a correct effluent quality. So Anamox, Anamox bacteria, if you don't know them, is curious bacteria. They tend to form red granules, so it's kind of curious. What they do, they take ammonium and nitrite anaerobically and without COD, and they transform it into nitrogen gas. So we don't need the COD for denitrification, and we can use it previously to produce more biogas, and we don't need oxygen. Okay. Okay, let's see some results about the effluent of this reactor. We are here several months of operation, and we can see that in many days with few stabilities for being a pilot, we have effluent with less than 8 milligrams per liter of nitrogen. In the effluent, what we have is basically ammonium. Nitrite and nitrate are never present. So we think that it works pretty well. Finally, we did an energy balance about comparing this configuration with a conventional wastewater treatment plant, okay, to know kilowatts per hour per cubic meter of treated wastewater. To compare this with conventional, okay? So on my left, on your left, we have the program OX diagram, and on the right we have the La Garriga wastewater treatment plant. Is the plant where the pilot is located. It's a conventional plant, okay? And then we have the sludge flows, okay? And with these sludge flows, we took samples and we did biomethane potential tests, okay, to simulate anaerobic digestion and to be able to quantify this energy balance, okay. Also with experimental data, we did the mass flows and mass balance to finally calculate the energy balance. The results of the energy balance, we can see them here, okay. So the program OX configuration implies 23% lower, or would imply 23% lower total energy consumption, okay, with aeration, physical processes, and so on. 84% higher of energy recovery with methane in anaerobic digestion, okay, we produce more sludge, more biogas. And finally, balancing the recovery with the consumption, we would have a plant with a 44% lower energy consumption, okay? So in La Garriga, you can see would be 0.46 kilowatts per hour per cubic meter, and applying program OX, we would lower it to 0.26. So in the end, this is an efficient process. We have less consumption, more biogas production, so that's the idea. Now we are working on the upscale of the process. We will try it in full scale. Okay, we will go, the pilot plan is 1.5 cubic meters per day, and we will try it to 400 cubic meters per day. This is a project funded by the European Union in PRIMA program. The project is called SportMed. You can check it out on the website. And now we are doing the construction is already in execution, and this summer we will begin with the startup. So I hope this operation will go well, and in a future we can apply this technology anywhere. So thank you very much, Oman Water Week, for the acceptance of this presentation, and thank you very much for the attention.
Thank you for that presentation. It's nice seeing sort of fresh R&D results. I have to admit, now that I'm managing R&D, I miss going into the lab. So now we're on to our last, but definitely not least, presentation for the day. Our last speaker is Mr. Abdullah Al-Uwaid, civil engineer graduate from SQU with over 15 years experience in the wastewater sector. He works on management of wastewater projects for NEMA Dhafar Services, and has played a pivotal role in successful execution and management of several major wastewater projects. Please join me in welcoming Mr. Abdullah Al-Uwaid to the stage, and he's going to be talking about a case study of treated water injection through recharge wells.
Assalamu alaikum wa rahmatullah. First of all, welcome all of you. I think this is not the right time for presentation because all are tired going back to home. but we will try not to take that much time. Just here we will tell you a story about a project executed by us in the south side of Oman in Salalah, which is injection of treated water to the groundwater in Salalah coastal area. Salalah Sanitary Drainage Services Company was established in 1997, and the wastewater system in Dhufar was the first wastewater system in Oman. During the study of wastewater system, Dames and Moore, they suggested to have injection recharge wells, injection treated water to the recharge wells on the coastal area of Salalah. And in 1999, also, Mott McDonald's did a study and recommend the same to protect the pollution. We have constructed the recharge wells and operated in 2002. In 2013, HMR consultancy, they did consultancy services feasibility study of this injection, and they focus on impacts of risks, sustainability of the same, and the results was in enhancing and encouraging, recommending to continue starting injection with the benefits, which we will talk about it later. Last year, we are having also consultancy services doing by ISAC. Part of it, it will also focus on the recharge wells. Dr. Muhat already he talks about the part of it on his presentation. We will try on this presentation to focus on other details which we are having. Here, if you see, this is Salalah city. If you see this, the sea is nearby to the farms in Salalah. What we did here, we have constructed 48 recharge wells on the beach, on the coastal area, and we are connected treated water to those recharge wells. As you can see here, the DI line, which is feeding the recharge wells, is about 22.5 kilometer. The diameter varies from 300 to 800. Also, the depth of the recharge wells is 48 meter. Its demand is around 9.8 million meter cube per year, which is around 27,000 cubic meter per day. Also, as you see that it is distributed there on the coastal area, plus some recharge wells on the Gerziz farm, which was converted later to a residential area. This is the same plan which was there by Dames and Moore in 1993. This is here, as you can see, the picture of our recharge well at site. Here I am going to highlight the main findings and of the feasibility study which has been done in 2013. We discovered that the aquifer level has been increased from 1 kilo to 2 kilo in the injection area. Also, the porosity of the area there is around 35%, which is fair enough. Also, the nitrogen nitrate has been decreased and it is coming on the allowable and acceptable range. Plus, the sanitary and the total dissolved solid has been decreased to be less than 2,000 milligram per liter. As you can see here at the left side, this is directly, immediately after the injection. We started the injection in 2002, August, and directly on the next year, 2003, Ministry of Municipal and Water Resources there that time, they compare the historical data which they are having with the data after that, and it's clearly shown that the salinity is coming down. Also, the main benefits of recharge well, as we see, and as already Dr. Muhammad said before, it is pushing the salt water and the seawater back because we are having actually high transmissibility and permeability in the groundwater there in Salalah. By the way, the geographical of Salalah is coming from north toward the sea. So this also helping the injection of treated water to the area and pushing the salinity back, which will improve the quality of groundwater and also ensure the sustainable of water and security of water. Also, it is maintaining ecosystem balance. As you can see here also on the right side, same reference bringing from Ministry of Municipal Regional at that time, showing that the level of the level of the water in the Salalah city coastal area is increasing, as you say, 2005, which is after injection, compared to 2000, which was before injection. Of course, there are many risks associated with the recharge wells, which should be considered in any such cases, like seawater intrusion, that the possibility will be there if you are not starting injection continuously. Also, the treated water should be free of any microbial agents, which should be tested regularly, which we are doing. Also, fecal coliform may be presence will be there for unserved areas, which is not having any network on the area. But in our case in Salalah, all the area there around are already served with the network. So wastewater network is available. Also, many challenges are there. Of course, the operation and maintenance of the recharge well, also it is there. It has to be, and we will show you the flushing of these recharge wells. It needs also to protect the groundwater by continue injecting the treated water. Also, if we are having around any farming, improper farming or improper use of water or wells there, maybe will affect also as well. On the other side, currently we are feeding this treated water to the area free of cost. So our treated water is going as free. So this in the future, when the usage of treated water is high also, it can be a challenge to continue with the same. As we are recommending toward this enhancing artificial recharging, we have to have a cost-benefit analysis on the same. Also, we have to do assessment for the existing recharge wells, which recharge wells has to be in, if any blockage is there or overhauling, it will be needed for this. Also, as Dr. Mahad say that he is already showing that mode flow 3D, it can be done, which we can get benefit from that also to see. On the other side, if this treated water is available in future, more recharge wells can be added to other areas. Also, we can use the wetlands like what is here in Al Ansab or any other areas that to discharge the treated water to that areas. Here also, in order to maintain the sustainable of groundwater, we have to continue with the injection of treated water to the groundwater. Also, we have to have natural source available. We need to have also many other further studies which can and monitoring plans for the same in future. Here, as you can see, this is the recharge well in Salalah, the construction wells drawing, which shows that how the recharge well is built there. We are doing some flushing procedure by removing the cabs and injecting some chemicals and acidic for antifoams also there, which will maintain the workability of the recharge wells. That's all, and thank you very much.
Thank you very much for that excellent last presentation and for all the presentations. If the panelists and speakers can please make their way to the front for questions. I'm sure the audience have, we've already got our first few questions. Perfect, I think.
Hello, Ilyas Sadi, project engineer for Surica Veolia. Following the promising results of the Salalah study on aquifer recharge, what is the current perspective of the authorities on this initiative, and do you foresee any regulatory developments to support or expand such practices? Particularly in regions like Batina Coast, where salinity is also a growing concern. Thank you very much.
The question to me, I think, yeah?
Yes.
Yes. Actually, here in Salalah, we have done this practice, and we are continuing with the same. When we did this recharge wells there, we are having also monitoring wells beside it, which is daily and continuously we are taking samples for testing. And this also, it is approved by different authorities there in our area. Also, the study which has been done in 2013, it was approved by MECA that time, Ministry of Environmental. And till date, we are still continuing injecting the same. And the results so far was good. And also, now we are having consultancy services will also having a further study on the same. I don't know if I understand your question.
Also, I can. Okay. As I mentioned also, when we inject injection in the third layer, layer C, which is 48 meter below the surface, air surface. And the agriculture pumping from layer 1 or layer A, which is only 5 meter or 10 meters above from the surface. So there are no direct mixing between the two layers. The layer where we inject and the layer where the agriculture used to pump for their agriculture use. So no impact, no impact because mixing is not there. If some mixing will happen, it will happen only after dilution. After this injected water was diluted with the brackish water in the groundwater, so that maybe some, dilution will be there, but it's, the layers are different layers. So the impact is no impact will happen because of this injection system. And then we advise also if it will happen in other places, that's in Salalah. It will happen in Batana. They should follow this procedure also. They inject deep, and the agriculture should use to pump from the layer 1 or the upper layer. And also they shouldn't allow the agriculture to, pump or to dig wells to the third layer or second layer. Otherwise, it will be a risk. The Ministry of Agriculture should also make a regulation about that. No one should, make their wells deep to the layer 3. Otherwise, if there is also injection is there, so mixing will happen. Then he might pump mixed treated wastewater with groundwater. Then it might affect the agriculture if it's vegetable or fruits.
Perfect. But, I think what you're really highlighting is the essential need to really incorporate scientists and researchers in any policy, in any projects that happen, so that people can learn from that experience and make sure that that advice comes through. Was your question answered? Perfect. Next question. Any others? Okay, well, that's good because it means that I get a chance to ask my questions. Maybe to Siva Kumar. That was interesting technology, and I know there's quite a few people that were interested. I was interested about the cost and how that is compared to the other technologies out there.
Yeah, cost perspective, definitely it is 30% cheaper than the conventional technologies, and the reliability will be compared to conventional technology, it will have more reliability, which has proven. In 2022 we started the plant. It has been running for continuously, and before that it was only maximum 65 to 75% recovery, and energy consumption wise it was around 0.6 kilowatt hour per meter cube. When we started this plant it was around 0.4 to 0.5, so you have a 10 to 15% savings also in terms of energy, and also CIP chemicals. Before that, due to scaling and fouling, it's become like every month you used to do the CIP. Now last 3 years we have done, because we are doing the O&M operation and maintenance also, so only 10 CIPs we have done.
Okay. Perfect. Any addition, or I go on to my next question? Was there somebody? No? So my other question was to Dr. Mohammed. My understanding is there's been some work looking into NEMA in Oman and sort of which solutions are best for us here. What would you say are the best? Because I mean, you highlighted a number of different technologies. So what would you recommend, or what do you think is a good solution here?
So we developed multiple scenarios actually, because what I highlighted in the conclusions, that we lack market studies to know what are the opportunities for each scenario. So we developed the scenarios with the cost and everything else. Now there is this piece of information missing in order to choose one scenario or another, and depending also on the location of the treatment plants, because a remote treatment plant cannot be integrated with a bigger scheme because of the cost of transportation. So each case will be different, but you need this market study to know what are the best scenarios for each case. Okay?
Thank you for that. Maybe I'll go to Oriol and talk about scalability and scaling up. At the moment, I think you indicated that you're starting the project. What stage are we at? And maybe, I mean, because we're talking about innovation here, so what are some of the challenges with kind of doing that and innovation in this field?
Well, now the challenge is basically, we know that it works at pilot, so we need to focus on the control of the process. We need to have stable effluent concentrations and so on. But I think that now it's more an engineering difficulty rather than research. It's also research, but I think that it's just to operate, work really hard on having trustable data and information, and afterwards, after 2 years of good operation, I think that you will be able to go to the authorities and try to do the first real implementation.
Sounds good. I think there was a question in the audience.
Can I ask? Can I ask a question?
You want to ask a question?
I want to ask Abdullah.
Okay.
Because we integrate, me and Abdullah, we integrate. But, and you see that I mean, our colleagues also, I think they are happy that they will produce the treated wastewater. But we said we have a solution for it. You can inject it, and we can, I mean, balance our aquifers. I mean, this is another, I mean, advantage for the treated wastewater. But unfortunately, I mean, some of the companies, for example, like Nama or some other, they don't want to inject the treated wastewater. Why? Because sometimes it's free, and they want to sell the treated wastewater instead to companies, for example. And so this is also, if they don't inject this water and they sell it, then we cannot balance our groundwater. I mean, so they have to balance this. I mean, for example, 50%, they inject the groundwater so we can have salinity, and 50% they can sell. Why? I mean, they don't inject? Because it's, they don't, maybe the government will not pay the cost of the treated water which they will inject, I mean. So this is a question to Abdullah. I heard about that. I mean, they are thinking this way.
Thank you, Doctor. Actually, what we are doing now we are having excess treated water in Salalah. And I think also here in Nama water, they are having excess treated water. While we are having excess treated water, we are injecting to the recharge wells. On the other side, on the future, there will be a challenge that we will reach to a point that we are having demand from other customers to have recharge wells. So at that end, there will be a challenge to continue injecting free of cost, but it can be a part of collaboration between, yes, as a social responsibility, or also other authorities in the government, like Ministry of Agriculture or water resources teams on different departments, that they can have some understanding between them and having some way of how to deal with it. Yeah.
So I think what's clear is that it will take a lot of, at the end, collaboration and work with different entities at that point to decide what is the most sustainable solution. I think there are the last two questions over there, and then we'll come down.
Maybe tell my colleagues, Mike, get ready. I'm here. Here. Okay, can I just take the advantage of the time till his mic will be ready? I have a comment. I don't have a question. My comment is like, in this kind of session, we have new technologies for wastewater, which is new to Oman and many of the Middle East countries. It's good to have some people from policymakers, people from regulation. The things what they are doing in Salalah or somewhere else, they need to be appreciated and be guided. Rather than just do it for free or just for these kind of technologies need to be tested, need to be appreciated, need to be even guiding the companies themselves what kind of technology to be used in the next coming years. They should be the people who have a helicopter view and where we need to follow. This is my only comment.
No, excellent. I think, like you said, it's very important in meetings like this to make sure that you have people from the companies, the policymakers, the different stakeholders all working together so that we see, and I think a few of you talked about some of the challenges in implementing and getting these technologies on ground.
I have a question for Mohammed Murad. You mentioned in some slide from the anaerobic process will produce biogas. So for the biogas, what is the role for the biogas can play in achieving energy independence, especially here in Oman?
I think I mentioned that of course, it varies depending on the quality of the sludge, on many parameters, but currently, let's say as a maximum, it can achieve like 60% of the electricity need of the wastewater treatment plant.
Because in Oman, I think we didn't have biogas plant. I think so. Not yet.
No, not yet in Oman.
Yes.
No, not yet.
So that's why.
Sorry?
So that's why I ask you this question.
No, in Oman, no. It was general. It was the calculation I did is theoretical, considering all the sludge.
So mean that biogas we can we can transfer the biogas to the electricity.
Yes.
In the future.
Yes. It's done everywhere.
Okay.
In Oman, currently, it's not done. And in the region in general, it's not yet. In Saudi Arabia, from out of 130 treatment plants, you have only 3 or 4 having biogas. But the main reason, I also mentioned that energy is very cheap in the region, okay? Compared to Europe, which is 5 to 6 times more expensive, and then it makes more sense to develop these projects. But now it's let's say all projects I know of in the region for large wastewater treatment plants, they all have biogas.
And I will say there are a number of biogas projects in the pipeline in Oman.
Exactly. So one of them, we did like a feasibility study for one of them when we developed a strategy, sludge strategy for Oman last year.
Last question.
Here is Ayman Termani from EPC Contractor Company Innovation House. My question for Mr. Oriol about this pilot study. Was there expectation or study about the increase in capex in compared as percentage, because some additional stage are added like SBR? Is there some
capex? You mean the operational
capital expenditure?
Considering the construction and
exactly.
Well, considering the we have not calculated the increase or reduction cost of the construction. We will do it now with this new project, but we don't expect to be more expensive. I mean, we can reuse, if we have to build it in an old wastewater treatment plant, we can reuse tanks and add, if maybe a new tank or something. But the thing is that you have the safe in oxygen, for thanks to the partial nitritation and so on, and more biogas production. So we think that in the end this will be very worthy compared to the construction. So
energy consumption is so promising.
Exactly.
So to build a case for our customer, to the end client, to know the ROI, okay, this increase in capex, how it will be returned, it would be nice to be added to the study.
Yeah, sure.
On certain scale.
We are not yet, I think, on that point. We just, in the R&D department, we did this pilot. We didn't know if it would work, so it worked. And now we are going to try it in a higher scale. It will be a pilot.
So let's hope in next Oman week, next year, to
sure.
hear results.
I hope.
Good luck.
And then maybe with what you ask. Yeah.
Thank you.
Perfect. We'll need to close there because of time. Thank you all for attending and listening, and thank you very much to all the speakers for your insightful presentations.
Thank you, Dr. Farah, for your excellent moderation. We invite you all to have a group photo. Then we invite Dr. Farah to give our speaker appreciation certificate. Please. Starting with Siva Kumar. Dr. Mahad Isa. Mr. Marcus Vollmer. Mr. Muhammad Murad. Mr. Oriol. and Mr. Abdullah Salim. And now I would like to invite Dr. Buthaina to give appreciation trophy to our moderator, Dr. Farah. Please, Dr. Buthaina, come to the stage. Thank you all for attending today. We are closing the municipal program. Thank you for attending the past 2 days. Tomorrow we are having the industrial program and we are having a hydrogen workshop. See you inshallah tomorrow.